There is something strange about the universe that we often forget. Among hundreds of billions of galaxies, countless stars being born and dying, planets wandering through the darkness, and enormous black holes quietly consuming matter, there are phenomena so rare that humanity could spend an entire lifetime waiting for a single chance to witness them. And sometimes, the rarest thing is not the most distant. It is something that appears for only a fleeting moment, or something that can exist only when a series of nearly impossible conditions happen at the same time. Tonight, we are going to begin a journey like that. 100 of the rarest phenomena in the universe. We will encounter planets orbiting the remnants of neutron stars, worlds wandering alone between the stars, ancient stars carrying the chemical memories of the early universe, magnetars with astonishingly powerful magnetic fields, and invisible black holes that can only be recognized by the way they bend light. And beyond them, we will encounter radio signals that last only a few milliseconds, yet may have traveled for billions of years before finally reaching Earth. But perhaps the most fascinating part is not hidden in those enormous numbers. Carl Gustav Jung spent much of his life reflecting on the things that exist beneath the surface of conscious awareness. And when we look into the universe, we encounter something remarkably similar. What we see is only the surface. Behind the light of a star may lie billions of years of history. Behind a tiny signal may be the story of an entire galaxy. And behind our questions about distant worlds, there may be a much deeper question about ourselves. Why did life appear here? Is intelligence common throughout the universe? Or are we living inside an extraordinarily rare exception? During tonight's journey, you do not need to find the answers right away. Just listen. Let your imagination expand. Let distances of billions of light years slowly feel a little closer, and allow your mind to gradually drift away from the noise of today. Welcome to the channel, where we explore the deeper stories of the universe, humanity, and the hidden world within the human mind. If you enjoy peaceful journeys like this, subscribe to the channel, turn on notifications, and join me as we begin tonight's voyage. Now, make yourself comfortable. Close your eyes, take a slow breath, and let the universe tell you about 100 of the rarest things humanity has ever discovered, the rarest things in the universe, and the question of life. Try closing your eyes for a moment, and imagine that above the roof of your familiar home lies a black ocean so deep that no language could ever fully describe it. Within that ocean are hundreds of billions of galaxies, and within each galaxy are billions of stars, distant worlds, black holes, clouds of gas, ancient remnants, and phenomena that humanity does not even know how to name yet. We often imagine that the most extraordinary things in the universe must be enormous, brilliantly luminous, or violently powerful. But tonight, we are going to look at the universe differently. We are going to search for the things that are rare, not only rare objects, but also states that can exist only when countless conditions happen to align, signals that survive for only a fleeting moment, and fragile traces that may help us answer a question humanity has carried since ancient times. Are we truly alone in the universe? From the perspective of Carl Gustav Jung, the unknown outside us can sometimes reflect the unknown within us. And so, the journey into the rarest phenomena of the universe is not only a journey through astronomy, it is also a journey into the deeper regions of the mind, where we encounter our own smallness, our loneliness, our desire for connection, and our questions about the meaning of existence. Jung once wrote in the Red Book, "The world of the gods and spirits is truly nothing but the collective unconscious inside me." Although these words were written within a very different psychological context, they invite a gentle thought. The things that make us marvel at the night sky may sometimes be the same things we are trying to understand within ourselves. And perhaps the first thing we need to change is the way we understand the word rare. Something rare does not necessarily have to be tiny or almost invisible. It could be a massive star that exists for only a brief stage of its life. It could be a planet formed under circumstances that are almost impossible to reproduce. It could be a radio signal lasting only a few milliseconds, yet traveling for billions of years before reaching instruments on Earth. Or, perhaps most astonishing of all, it could be the emergence of a civilization capable of asking questions about the very universe that gave birth to it. So far, Earth remains the only place where humanity knows for certain that life exists, and especially life capable of developing complex technology. That does not mean we have proven that we are the only civilization. It simply means that we have not yet found confirmed evidence of an extraterrestrial civilization. Between those two statements lies an enormous gap, and it is precisely that gap that makes the question so fascinating. Over the past few decades, astronomers have discovered thousands of exoplanets. Some worlds orbit extremely close to their host stars, completing an orbit in only a few hours. Some may possess oceans, atmospheres, or conditions completely unfamiliar to Earth. Some planets wander between stars without being gravitationally bound to any sun. Others orbit neutron stars, incredibly dense remnants left behind by dead stars. Each discovery is like a small door opening in the darkness. But a planet capable of supporting life does not necessarily mean that life exists there. And a world containing life does not necessarily contain intelligence. Even if intelligence emerges, it may never develop technology powerful enough to produce a detectable signal across interstellar distances. That is why the question of extraterrestrial life is not simply, is anyone out there? It is also, if someone is out there, how long have they existed? Do they want to communicate? Have they developed technology advanced enough for us to recognize them? And could their civilization survive long enough for two distant worlds to happen to notice one another? This is where the concept of technosignatures becomes particularly fascinating. Instead of looking only for tiny organisms or biological traces, scientists have begun searching for evidence of technology. Unusual radio signals, unusual energy sources, or phenomena that might suggest the existence of an advanced civilization. So far, no technosignature has been confirmed as evidence of an extraterrestrial civilization. But the fact that we are capable of designing methods to search for such evidence tells us something extraordinary. A small creature on a small planet has begun looking into the darkness for other forms of intelligence. And as night falls, perhaps we should allow that question to exist without rushing to answer it. Because sometimes, the value of a question is not found in how quickly it is solved, but in its ability to expand the mind. Jung once wrote in Memories, Dreams, Reflections, "The privilege of a lifetime is to become who you truly are." Perhaps the exploration of the universe works in much the same way. We look toward the stars, searching for what exists beyond us, while at the same time discovering who we are within a universe too vast to comprehend. Tonight, we will gradually pass through strange worlds, ancient stars, wandering planets, invisible black holes, brief signals from deep space, enormous structures, and phenomena that science still cannot fully explain. Some have been directly observed, some are supported only by indirect evidence, and some remain delicately balanced between hypothesis and discovery. So let the room become a little quieter. Let the sounds of today slowly fade away. You do not need to remember everything. Just listen, as though we are drifting very slowly together through the darkness between the stars. This is a journey through 100 of the rarest phenomena in the universe, and also a journey toward understanding what makes our own existence so extraordinary. You are listening to Channel Name, where stories about the universe, the human mind, and the deeper mysteries of existence are told at a slow and gentle pace, perfect for the hours before sleep. If you enjoy journeys like this, subscribe to the channel, leave a like, and stay with us, because coming next, we will open the first door and step into one of humanity's oldest, most mysterious, and most difficult questions. If the universe is truly this vast, why, after all this time, have we still not heard the voice of anyone else? Unimaginable worlds in the universe. Let your mind drift away from Earth just a little farther. If the previous chapter brought us to questions about life and rarity, we will now enter worlds that seem as though they were created from the imagination of a science fiction writer. There are planets orbiting the remnants of dead stars. There are worlds wandering alone through interstellar darkness. There are places where rock may exist in a molten state. And there are planets orbiting two suns at once. The strangest thing is that most of these worlds do not require our imagination to exist. They have been inferred or observed through astronomical data collected by humanity across distances of tens, hundreds, and even thousands of light years. From Carl Gustav Jung's perspective, unfamiliar images can have a special power over the mind because they remind us that the world we know is not the entirety of reality. When we look into the night sky, we naturally imagine that a planet should resemble Earth, a rocky sphere orbiting a stable star, with day and night, oceans, and an atmosphere. But the universe has no obligation to follow humanity's familiar expectations, and these unusual worlds are quietly expanding our understanding of what a planet can actually be. One of the most astonishing discoveries comes from the PSR B 1257+12 system. There, astronomers discovered planets orbiting a pulsar, a rapidly rotating neutron star, an incredibly dense remnant left behind after the violent death of a star. Try to imagine that before falling asleep, a star that once burned brightly ended its life in a catastrophic explosion. Its core collapsed into an object only a few dozen kilometers across. And yet, planets continued orbiting that remnant. It feels like a story about survival written in the language of the universe. A world can survive the death of the very star that gave birth to it. And this brings to mind something deeply Jungian. Sometimes what appears to be an ending is not truly an ending. An old structure may disappear, yet from what remains, an entirely new form can emerge. In the Red Book, Jung wrote, "The spirit of the depths from time immemorial, and for all the future, possesses greater power than the spirit of this time." We should not use this statement as a scientific explanation for planets around pulsars, but it evokes a beautiful image. Beneath everything we can immediately see, there are deeper layers that the human mind has not yet fully understood. And if a planet can survive around the remnant of a dead star, what happens to planets that no longer have any star to orbit? That brings us to the world of rogue planets, planets wandering between the stars. They may once have belonged to planetary systems, but through violent gravitational interactions, they were ejected from their original orbits and became solitary travelers through space. There is no ordinary sun rising every morning, no familiar seasons, no sky resembling the one we know, only profound darkness and the faint light of distant stars. But loneliness does not necessarily mean complete inability to exist. Some rogue planets may retain internal heat through geological activity or radioactive decay. If they possess thick layers of ice and subsurface oceans, such unusual environments could even raise questions about whether complex chemistry and perhaps life might exist there. We still do not know whether such worlds contain life, but even the possibility is enough to challenge one of our oldest assumptions, that life must necessarily exist beneath the light of a star. Then there are planets at the opposite extreme, worlds so close to their stars that their surfaces may become oceans of molten rock. These are sometimes called lava planets. They orbit their host stars at extraordinarily close distances. Some complete an orbit in only a few hours or days. Temperatures on the star-facing side can become so extreme that rock itself melts. If vast lava oceans exist across their surfaces, these worlds would look nothing like Earth. No blue oceans, no forests, no ice, only molten rock, strange atmospheres, and the fierce light of their host stars. But the universe contains worlds whose chemistry may surprise us even more. Some carbon-rich planets have been hypothesized to contain relatively high proportions of carbon in their composition. Under the right pressure and temperature conditions, carbon can form different minerals, including diamond. This does not mean we have confirmed a literal diamond planet in the popular sense. Models of the structure and composition of carbon-rich planets still depend on the specific conditions under which they formed. But the idea demonstrates how familiar materials from Earth can behave very differently under extreme cosmic conditions. And then there are Chthonian planets, hypothetical worlds that may represent the remaining cores of gas giants after their outer atmospheres have been stripped away by their host stars over time. Imagine a planet once surrounded by an enormous envelope of gas, but because it lies too close to its star, that atmosphere gradually disappears. Eventually, what remains may be a hot, dense, exposed planetary core. A world like this resembles a memory, gradually stripped apart by time. And it brings to mind the way Jung explored the human psyche. When the layers of social masks, roles, and familiar stories are removed, what remains at the deepest level? Perhaps this is also why strange planets fascinate us so deeply. They are not merely different from Earth. They force us to question the very things we once assumed were obvious. Some ultra-short period planets complete an orbit around their stars in less than a single Earth day. Imagine living on a world where a year is shorter than our day. If a human being could stand upon such a planet, how strange would the concept of time become? A complete orbital cycle that we would call 1 year could end before a person even finishes a long night's sleep. Try closing your eyes for a moment, and imagine that above the familiar roof over your head lies an ocean of darkness so deep that no language could ever fully describe it. Within that ocean are hundreds of billions of galaxies, and within each galaxy are billions of stars, distant worlds, black holes, ancient remnants, clouds of gas, and phenomena that humanity does not even know how to name. We often imagine that the most extraordinary things in the universe must be enormous, brilliantly bright, or violently powerful. But tonight, we are going to look at the universe differently. We are going to search for the rare, not only rare objects, but also states that can exist only when countless conditions happen to come together. Signals that survive for only a fleeting moment, and fragile traces that may help us answer a question humanity has carried since ancient times. Are we truly alone in the universe? In the perspective of Carl Gustav Jung, the unknown outside us can sometimes reflect the unknown within us. And so, the journey through the rarest phenomena in the universe is not merely a journey through astronomy, it is also a journey into the deeper regions of the mind, where we encounter our smallness, our loneliness, our desire for connection, and the question of what existence itself means. Jung once wrote in the Red Book, "The world of the gods and spirits is truly nothing but the collective, unconscious inside me." Although this statement was written within a very different psychological context, it invites a gentle thought. The things that fill us with wonder when we look toward the heavens may sometimes be connected to the very things we are trying to understand within ourselves. And perhaps the first thing we need to change is our understanding of the word rare. Something rare does not necessarily have to be small or almost invisible. It could be a massive star that exists in a particular stage for only a very brief period of cosmic time. It could be a planet formed under conditions that are extraordinarily difficult to reproduce. It could be a radio signal lasting only a few milliseconds, yet traveling billions of light years before reaching instruments on Earth. Or, more astonishingly, it could be the emergence of a civilization capable of asking questions about the very universe that gave birth to it. So far, Earth remains the only place where humanity knows for certain that life exists, and especially that intelligent life capable of creating complex technology exists. That does not mean we have proven that we are the only civilization in the universe. It simply means that we have no confirmed evidence of another extraterrestrial civilization, and between those two statements lies an enormous gap. That gap is what makes the question so fascinating. Over the past few decades, astronomers have discovered thousands of exoplanets. Some worlds orbit extremely close to their parent stars, completing an orbit in only a few hours. Some may possess oceans, atmospheres, or environments completely unlike anything found on Earth. There are rogue planets wandering through interstellar darkness without being gravitationally bound to any star. There are worlds orbiting neutron stars, incredibly dense remnants left behind by dead stars. Every discovery feels like a small door opening in the darkness. But a planet that might support life does not necessarily mean that life exists there. And a world containing life does not necessarily contain intelligence. Even if intelligence emerges, it may never develop technology powerful enough to produce a signal detectable across interstellar distances. That is why the question of extraterrestrial life is not simply, is anyone out there? It is also, if they exist, how long have they existed? Do they want to communicate? Have they developed technology advanced enough for us to recognize them? And could their civilization survive long enough for two distant worlds to ever notice one another? This is where the concept of techno-signatures becomes especially fascinating. Instead of searching only for tiny organisms or biological traces, scientists are also beginning to search for signs of technology, unusual radio signals, strange energy patterns, or phenomena that could potentially indicate the presence of an advanced civilization. So far, no technosignature has been confirmed as evidence of an extraterrestrial civilization. But the fact that we are capable of designing ways to search for such evidence already tells us something extraordinary. A small species living on a small planet has begun looking into the darkness for other minds. And as night falls, perhaps we should allow that question to exist without demanding an immediate answer. Because sometimes, the value of a question does not lie in how quickly it can be answered. It lies in its ability to expand the mind. Jung once wrote, in Memories, Dreams, Reflections, "The privilege of a lifetime is to become who you truly are." Perhaps the same idea applies to our exploration of the universe. We look toward the stars, searching for what exists beyond us, while at the same time discovering something about who we are within a universe so vast that the human mind can barely comprehend it. Tonight, we will move through strange worlds, ancient stars, wandering objects, invisible black holes, brief radio flashes from deep space, enormous cosmic structures, and phenomena that science still cannot fully explain. Some have been directly observed, some are supported only by indirect evidence, and some still exist on the fragile boundary between hypothesis and discovery. So let the room become a little quieter. Let the sounds of today slowly fade away. You do not need to remember everything. Just listen, as if we were drifting very slowly through the darkness between the stars. This is a journey through 100 of the rarest things in the universe, and also a journey toward understanding what makes our own existence so extraordinary. You are listening to Channel Name, where stories about the universe, the human mind, and the deepest mysteries of existence are told in a slow, gentle rhythm for the hours before sleep. If you enjoy journeys like this, subscribe to the channel, leave a like, and stay with us. Because in just a moment, we will open the first door and step into one of the oldest, most mysterious, and most difficult questions humanity has ever asked. If the universe is truly this vast, why, after all this time, have we still not heard the voice of anyone else? Worlds beyond imagination in the universe. Let your mind drift a little farther away from Earth. If the previous chapter brought us to the question of life and rarity, we will now enter worlds that seem as though they were imagined by a science fiction writer. There are planets orbiting the remains of dead stars. There are worlds wandering alone through interstellar darkness. There are places where rock may exist in molten form. And there are planets orbiting two stars at the same time. The strangest part is that most of these worlds do not require our imagination to exist. They have been inferred or observed through astronomical data collected from distances of tens, hundreds, and even thousands of light-years. From Carl Gustav Jung's perspective, unfamiliar images can have a special power over the mind because they remind us that the world we know is not the entirety of reality. When we look into the night sky, it is easy to imagine that a planet must resemble Earth, a rocky world orbiting a stable star, with day and night, oceans, and an atmosphere. But the universe has no obligation to follow humanity's expectations, and these unusual worlds are quietly expanding our understanding of what a planet can actually be. One of the most astonishing examples comes from the system PSRB 1257 plus 12. There, astronomers discovered planets orbiting a pulsar, a rapidly rotating neutron star, an incredibly dense remnant left behind after the violent death of a star. Try to imagine that before falling asleep. A star once burned brightly, then it ended its life in a catastrophic explosion. Its core collapsed into an object only a few dozen kilometers across, and yet planets continued to orbit the remains. It feels almost like a story about survival written in the language of the universe. A world can survive the death of the very star that once shaped its surroundings. And this brings to mind something deeply Jungian. Sometimes what appears to be an ending is not truly an ending. An old structure may disappear, while something new emerges from what remains. In the Red Book, Jung wrote, "The spirit of the depths, from time immemorial and for all the future, possesses greater power than the spirit of this time." We should not use this statement as a scientific explanation for planets around pulsars, of course, but it creates a beautiful image. Beneath what we can immediately see, there are always deeper layers that the mind has not yet fully understood. And if a planet can survive around the remains of a dead star, what happens to planets that no longer have a star to orbit? That brings us to the world of rogue planets, planets wandering between the stars. They may once have belonged to a planetary system, but through powerful gravitational interactions, they were thrown out of their original orbits and became solitary travelers through space. There is no ordinary sun rising above them each morning, no familiar seasons, no sky resembling the one we know, only darkness, cold, and the faint light of distant stars. But loneliness does not necessarily mean complete impossibility. Some rogue planets may retain internal heat through geological activity or radioactive decay. If they possess thick layers of ice and subsurface oceans, such unusual environments could even raise questions about whether complex chemistry might exist there. We still do not know whether such worlds contain life, but the possibility alone is enough to challenge an assumption that has existed for a very long time, that life must necessarily exist beneath the light of a star. Then there are worlds moving in the opposite direction, planets so close to their stars that their surfaces may become oceans of molten rock. These are sometimes called lava planets. They orbit their parent stars at extraordinarily close distances. Some complete an entire orbit in only a few hours or days. Temperatures on the star-facing side can become high enough to melt rock. If vast lava oceans exist across their surfaces, these worlds would look nothing like Earth. No blue oceans, no forests, no frozen landscapes, only molten rock, strange atmospheres, and the intense light of a distant star. But the universe still has worlds with chemistry that may be even more surprising. Some carbon-rich planets are hypothesized to contain relatively large amounts of carbon in their composition. Under the right pressure and temperature conditions, carbon can form different minerals, including diamond. This does not mean that we have confirmed a literal diamond planet in the popular sense. Models of the structure and composition of carbon-rich planets still depend on the specific conditions under which they formed. But the possibility shows us how differently familiar materials can behave when placed under extreme cosmic conditions. And then there are chthonian planets, hypothetical worlds that may represent the remaining cores of former gas giants after their outer atmospheres were stripped away by their parent stars over time. Imagine a planet once surrounded by an enormous envelope of gas, but because it remained too close to its star, that atmosphere was gradually stripped away. Eventually, what remained might be a hot, dense, exposed core. A world like this would resemble a memory gradually stripped of its layers by time. It brings to mind the way Jung explored the human psyche. When the social masks, roles, and familiar stories are gradually removed, what remains at the deepest level? Perhaps that is why strange planets fascinate us so much. They are not merely different from Earth. They force us to reconsider the things we once assumed were obvious. Some ultra-short period planets complete an orbit around their stars in less than a single day. Imagine living on a world where a year is shorter than one of our days. If a human being could stand on such a planet, how strange would the concept of time become? A complete orbital cycle, what we would call a year, could end before a person even finished a long night's sleep. There are also planets that orbit two stars at once, known as circumbinary planets. These worlds resemble planets from science fiction stories, where two suns appear in the sky. But they are not merely products of imagination. Several circumbinary systems have been observed, showing that nature can create structures far more complex than the simple picture of one planet orbiting one star. And if we stretch our imagination even farther, we can think about exomoons, moons orbiting exoplanets, rogue moons, which may become separated from their original planetary systems, and Trojan planets, theoretical configurations in which planetary mass bodies could share stable orbital arrangements around the same star. Many of these possibilities are still being studied. Some have significant observational evidence. Others remain theoretical possibilities waiting to be tested. And that distinction matters. The universe does not become less beautiful simply because we cannot confirm everything. In fact, it may be the gap between what we know and what we do not know that awakens our imagination most deeply. As the night grows quieter, try to imagine all those worlds existing somewhere out there. A planet orbiting the remains of a dead star, a lonely world drifting between the stars, a glowing ocean of molten rock beneath the light of a distant sun. A planet perhaps preserving traces of an evolutionary process that began billions of years ago. And perhaps, somewhere we have never seen, a moon is orbiting a planet that itself circles another star. We often think that we are discovering the universe, but perhaps, in a deeper sense, the universe is also helping us discover ourselves, because every time we encounter a world unlike Earth, we are forced to expand the boundaries of what we consider possible. And as those boundaries expand, the mind expands with them. Tonight, you do not need to remember the names of all these planets. Just keep one image with you. Across the endless darkness, countless worlds are quietly moving. Some are hot enough to melt rock. Some are so cold that almost no light reaches them. Some were born after the death of a star. Some may have been thrown away from their original families and now drift alone. And in that silence, our own Earth suddenly seems both incredibly small and incredibly precious. Perhaps that is the feeling we should carry with us into sleep. Reality is far larger than we once imagined, and the unknown does not necessarily have to be frightening sometimes. It is simply a door waiting for us to become quiet enough to open it. Strange visitors and mysterious objects of the solar system. Imagine that. On a very quiet night, when the lights in your room have gone out and the sounds of the day have slowly faded away, strange visitors are silently passing through the outer regions of our solar system. They make no sound, they leave no footprints, and sometimes they appear only briefly before disappearing back into the darkness. Some objects were born around another star and happen to pass through our cosmic neighborhood. Others have shapes so unusual that they force astronomers to reconsider what they once thought was familiar. and some lie so far away that light from them takes many hours to make its way back to us. If the previous chapter showed us how strange worlds can exist around distant stars, tonight we will move closer to home and explore some of the strange visitors and unusual objects that have entered or continue to inhabit our solar system. Perhaps one of the most famous visitors is Oumuamua. In 2017, astronomers discovered a small object moving through the solar system on a trajectory showing that it was not gravitationally bound to the Sun. It came from interstellar space, and after passing through our planetary neighborhood, it continued its journey outward. It was the first confirmed interstellar object observed passing through our solar system. The name Oumuamua comes from Hawaiian and is commonly interpreted as something close to scout or messenger from afar. But what made Oumuamua so fascinating was not only its origin, its shape, light-reflecting properties, and small non-gravitational acceleration that was not easily explained by simple gravitational motion led to extensive study and debate. Several natural explanations have been proposed to account for its behavior. At the same time, more adventurous ideas about an artificial origin have also been suggested. But there is no reliable evidence that Oumuamua was a device created by an extraterrestrial civilization. Perhaps the most beautiful part of the story is the uncertainty. An object arrived from a place we had never seen. It passed through our neighborhood, and then it disappeared. It is almost like a dream that we can remember only in fragments after waking. Carl Gustav Jung once wrote in Memories, Dreams, Reflections, "The privilege of a lifetime is to become who you truly are." In Jungian psychology, the statement points toward the journey of becoming oneself. But when we look at an object like Oumuamua, we can also sense something similar. Sometimes, confronting something unfamiliar reminds us that the world we know is only a small part of reality. 2 years later, in 2019, another interstellar visitor appeared, Dvi Borisov. If Oumuamua raised questions because of its unusual characteristics, Borisov appeared more familiar. It was an interstellar comet, displaying activity and structure that allowed scientists to recognize similarities with comets from our own solar system. What made it extraordinary was its origin. It was not born around the Sun. It formed in another planetary system, wandered through interstellar space, and eventually happened to pass through our region. Try thinking about that before falling asleep. The materials that make up Borisov may once have belonged to a distant planetary system around a star humanity has never seen. Perhaps billions of years ago, some gravitational interaction pushed it away from its birthplace. It drifted through darkness for an almost unimaginable length of time, and eventually, it passed by the Sun. Then it continued on its way. A visitor from another home, stopping by only briefly, leaving us a little information about where it once belonged. But the solar system also contains objects that do not fit neatly into the categories we have created. Consider active asteroids. These objects have orbits resembling those of asteroids, yet sometimes display comet-like activity, such as releasing dust or developing tails. They remind us that nature does not always respect the boxes humans create for classification. The boundary between an asteroid and a comet is not always a perfectly clear line. Farther out are the Centaur's objects whose orbits lie between different regions of the solar system and whose characteristics can overlap those of both asteroids and comets. They are almost like residents of a borderland, not entirely belonging to one world, yet not fully belonging to another. Perhaps that image is surprisingly close to the human psyche. We also tend to classify everything, right or wrong, light or darkness, familiar or strange, belonging here or belonging somewhere else. Yet the spaces between categories often contain the most interesting possibilities. Jung was deeply interested in the regions between consciousness and the unconscious, where dreams, symbols, and unrecognized psychological contents can emerge. In astronomy, a centaur exists in its own kind of borderland. Then there are celestial bodies, whose shapes are even stranger. Contact binaries are objects made of two major components that are physically touching, potentially formed through very gentle collisions and mergers. One famous example is Arakoth, an object in the Kuiper belt that the New Horizons spacecraft flew past in 2019. Arakoth looks almost like two small bodies joined together. It does not resemble a perfectly round planet. It looks more like an ancient memory preserved from the early solar system. What makes it especially fascinating is that the merger of objects like these may have occurred at relatively low speeds, allowing them to join without being completely destroyed. For this reason, Arakoth is considered an important fossil for understanding how small bodies may have accumulated during the solar system's earliest history. And when we look at it, we are looking into the past. Not a few hundred years, not a few thousand, but billions of years. Other asteroids make us think about the deepest interiors of planets. Metal-rich asteroids may contain large amounts of metal, and in some cases have been hypothesized to represent the surviving metallic cores of planetary bodies that were destroyed long ago. If that interpretation is correct, a small asteroid could be like a fragment of the metallic heart of a world that disappeared billions of years ago. A world that no longer exists, while the material memory of that world continues drifting through space. Something similar can happen with main-belt comets. These objects reside within the asteroid belt, but display comet-like activity, suggesting that ice can survive in regions closer to the Sun than simpler models once suggested. This does more than make the solar system more diverse. It also helps scientists reconsider how water and other volatile materials were distributed during the formation of the planets. Then there are hyperbolic comets, comets following open trajectories that may pass through the solar system only once before continuing outward. Some objects can have their orbits altered through strong gravitational encounters, while genuine interstellar objects entering from outside the solar system can display clearly hyperbolic trajectories. We live in a planetary system that may appear stable, but in reality, it is always moving. Objects are ejected, captured, colliding, redirected. Some remain for billions of years. Others visit only once. And farther out, there is Sedna. Sedna follows an extraordinarily long and distant orbit, carrying it far beyond the familiar regions of the solar system during a journey that takes thousands of years. Its unusual orbit has raised many questions about the dynamical history of the outer solar system. Perhaps Sedna preserved traces of a very distant era, when nearby stars were closer together and the young solar system existed within a much denser stellar environment than the one surrounding us today. We do not know the entire story, and perhaps that is exactly what makes Sedna beautiful. It exists in a place almost impossible to imagine, moving slowly through darkness, carrying a story humanity has only just begun to read. If we look at all these objects through the lens of Jung, we can see a familiar theme. The unfamiliar is not always something that needs to be removed. Sometimes, it is what helps us understand ourselves more deeply. Oumuamua came from another star system. Borisov carried material from another distant world. Arakoth preserves memories of the early solar system. Metal-rich asteroids may be remnants of worlds that no longer exist. Sedna remains at the distant edge, almost like a cosmic time capsule. All of them tell us something very quietly. The universe does not stand still. Everything is moving through somewhere. Some things remain. Some things leave. Some appear only once within an entire human lifetime. And just like the visitors who pass through our own lives, their value may not lie in how long they stay. Sometimes, it lies in what they allow us to see during the brief moment they are here. Now, as the night grows deeper, let those objects continue on their journeys. Oumuamua is moving farther away from the Sunday. Borisov has continued its journey between the stars. Sedna continues its enormous orbit through the darkness. Arakoth remains in the cold shadow of the Kuiper belt, and we only need to lie still and listen. Because somewhere beyond the almost endless expanse of space, ancient visitors continue moving very slowly. And in that silence, there is something beautiful to carry with us into sleep. We do not need to understand the entire universe to feel that we belong to it. Sometimes, simply knowing that we are here in one small corner of space, beneath a sky filled with worlds still waiting to be discovered, is already a miracle. Ancient stars and stars that look younger than their age. There are stars that, when we look up at the night sky, appear to be nothing more than tiny points of light. But if we look more deeply, each point may contain a story spanning billions of years. A story of birth, growth, transformation, and eventual death. And the strangest thing is that, in the universe, age does not always appear in the way we expect. Some stars belong almost to the childhood of the universe itself, existing from an era when galaxies were still beginning to form their earliest structures. But there are also stars within very old star clusters that should, by all appearances, be ancient and dim, yet unexpectedly appear bluer, brighter, and younger than their neighbors. When we quietly observe these paradoxes, we can find an intriguing parallel with an idea in the psychology of Carl Gustav Jung. Human beings, too, often carry memories and energies that seem to belong to the past, yet can transform and reappear in entirely new forms. Jung once wrote in the Red Book, "Whoever looks into the mirror of the soul sees himself." Perhaps ancient stars can also serve as mirrors like these. They do not simply tell us about the history of the universe. They also make us wonder about the way time leaves traces within ourselves. Let us begin with some of the oldest stars humanity has ever discovered. During the earliest generations of stars in the universe, there were almost none of the heavier elements that are familiar to us today. After the Big Bang, the universe consisted primarily of hydrogen and helium, along with a very small amount of lithium. Elements such as carbon, oxygen, silicon, iron, and gold had to wait for the first generations of stars to form, live, die, and release their enriched material into space. Because of this, a metal-poor star can function almost like a chemical fossil. Its composition preserves clues about the material environment that existed before many later generations of stars were born. One particularly remarkable example is SMSS J03136708, an extremely iron-poor star. What makes it important is not simply its age, but the chemical fingerprints it preserves. Stars like this help astronomers reconstruct the history of the earliest stellar generation stars that may have disappeared billions of years ago but left traces within the material of later generations. They are like ancient pages, accidentally preserved in an enormous cosmic library. And then we encounter a beautiful paradox: blue stragglers. Within an old star cluster, most stars have spent billions of years progressing through stellar evolution. Yet blue stragglers appear bluer, hotter, and brighter than they should be for their environment. They look almost like young people appearing among a community of the elderly. But their secret lies in interaction. Some may gain material from a companion star. Others may form through stellar collisions or mergers. In other words, their apparent age does not tell the entire story. This suggests a deeply Jungian thought. We are not always defined by our history. A person can carry wounds that are very old and still experience psychological renewal. A part of the personality that was once buried may return in a completely new form. In The Archetypes and the Collective Unconscious, Jung wrote, "The privilege of a lifetime is to become who you truly are." For a blue straggler, this rejuvenation is not magic in the ordinary sense. It is the result of interaction, exchange, and transformation. But that is precisely what makes the image so beautiful from a psychological perspective. The past does not necessarily have to become an unchangeable sentence. Elsewhere in the universe, Wolf-Rayet stars tell a very different story. These are extremely massive, hot, and luminous stars that often lose material through powerful stellar winds. Their outer layers are gradually blown away, exposing deeper layers of material beneath. If we imagine a star as a person with many layers of identity, this process almost resembles the gradual removal of those outer layers until the deepest parts become visible. And perhaps that is where our journey into the rarest things in the universe becomes something more than astronomy. Because sometimes, when we look deeply enough into the stars, we begin to see ourselves. There are stars that, when we look up at the night sky, seem to be nothing more than tiny points of light, quiet and distant, suspended in the endless darkness. But behind that peaceful appearance are stories so different from one another that they are almost impossible to imagine. Some stars have existed since the earliest chapters of the universe, carrying within their chemical composition the memories of generations of stars that came before them. Some stars belong to ancient stellar clusters, yet appear strangely young, bluer and brighter than their neighbors that have existed for billions of years. Some stars are slowly stripping away their outer layers, revealing deeper material that was once hidden from view. And others pass through extraordinary stages that last only for a fleeting moment before transforming into something else. If we look at these phenomena through the lens of Carl Gustav Jung, we can discover a theme that feels surprisingly close to our own inner lives. Time does not always tell the whole story of who or what we are. A person may carry a very long history and still change. A wounded soul can become alive again. Someone who seems to have been completely shaped by their past can still discover an entirely new part of themselves. So tonight, let us begin with some of the oldest stars we know. When the universe was still very young, heavy elements were almost non-existent. The Big Bang produced primarily hydrogen and helium, along with a very small amount of lithium, elements such as carbon, oxygen, silicon, and iron. The very elements that now seem so familiar to us had to be created through generations of stars. That is why, when astronomers discover a star with an extremely low abundance of heavy elements, they are not simply finding an old star. They may be looking at a chemical archive of the early universe. One famous example is SMSS J03136708. Its extraordinarily low iron abundance allows scientists to make inferences about the environment in which some of the earliest generations of stars existed. Those first stars have mostly disappeared. They lived, evolved, and eventually died billions of years ago, releasing material back into space. Their light has faded from the present sky, and their original forms are long gone. And yet, traces of them may still exist inside the stars that came after them. There is something deeply beautiful about that, when we slow down enough to contemplate it. In Jungian psychology, human beings are never completely separate from their past. Old experiences, memories, symbols, and unconscious patterns can continue to influence the way we see the world. But the past is not merely something we must escape from. It is also part of the history that created us. An ancient star does not need to become young again to have value. Its very age is what makes it precious. Its age turns it into a key that allows us to look backward into the history of the universe. And then we encounter an even stranger paradox: blue stragglers. Inside an ancient star cluster, most stars have already spent billions of years evolving. They should carry the appearance of old age, becoming cooler, redder, or moving into later stages of stellar evolution. And yet, blue stragglers appear bluer, hotter, and brighter than we would expect. They seem almost like young people appearing in the middle of a community that has been aging for billions of years. The secret lies in interaction. Some blue stragglers may gain material from a companion star. Others may form through stellar collisions or mergers. They are not, literally, turning back time. Instead, they receive additional material and energy that alters their evolutionary path and allows them to appear different from the stars around them. And here, we can see a deeply Jungian image. Human beings sometimes enter periods of their lives that other people cannot understand. Someone who has experienced years of suffering may suddenly discover a new sense of vitality. Someone who has spent years in silence may suddenly begin creating. Someone who thought they already understood themselves may unexpectedly discover a part of their personality that had never truly been allowed to live. Psychological growth is not always a straight line. Sometimes it resembles a star system with encounters, collisions, losses, exchanges, and relationships that transform the structure of who we are. Jung emphasized that becoming oneself is not simply about eliminating the parts of ourselves that we dislike. It is part of a process known as individuation, the gradual process through which a person becomes more conscious of, encounters, and integrates the different parts of the self. In that sense, a blue straggler can become a beautiful metaphor. Sometimes a new part of ourselves only appears after an encounter has changed our entire inner structure. Now, let us continue our journey and come to the Rarest stars. These are massive, extremely hot stars with powerful stellar winds capable of stripping away significant amounts of material. Their outer layers are gradually blown away into space, revealing deeper material that once existed beneath the surface. This image brings us close to one of Jung's most important ideas, the shadow. In everyday life, we often construct an image of who we believe we are: strong, kind, successful, calm, reliable. But behind that persona may exist emotions we would rather not see: fear, jealousy, anger, insecurity, desire, or even abilities we have never allowed ourselves to develop. Like a Rarest star losing its outer layers, psychological growth can sometimes require us to look through the familiar layers of our identity, not to destroy ourselves, but to recognize what is actually there beneath the surface. Then we encounter the yellow hypergiants, enormous yellow stars passing through an extraordinarily brief stage of stellar evolution. On the timescale of the universe, this phase is almost like the blink of an eye. And that is precisely what makes observing them so remarkable. Perhaps this is also a gentle reminder for us before we fall asleep. Not everything meaningful has to last forever. A moment of realization may last only a few seconds. A meeting may last only a few months. A decision may happen in a single evening, and yet its consequences can remain with us for the rest of our lives. Sometimes, the length of a moment has very little to do with the depth of its meaning. And finally, let us look toward the carbon stars. These stars can produce significant amounts of carbon and release carbon-rich material and dust into space. In some cases, this dust can surround the star so densely that its visible light becomes partially or even heavily obscured. But that dust is not simply a sign of an ending. Carbon is an essential element in the chemistry of life. The material released by aging stars can become part of the interstellar environment and, eventually, contribute to the formation of new generations of stars and planets. A star may die, but its material does not simply disappear. It becomes part of another story. Perhaps this is the most beautiful lesson that ancient stars can offer us. Not every ending is a loss. Not every form of aging is a decline. And the way something appears today can never tell the entire history of what lies within. Ancient stars preserve the memories of the universe. Blue stragglers show us that even an aging system can produce new vitality. Rarest stars remind us that outer layers can disappear, allowing deeper material to become visible. Yellow hypergiants remind us to appreciate fragile stages that exist only for a brief moment. And carbon stars quietly tell us that even when one journey comes to an end, its material and perhaps its meaning can continue traveling much farther. And perhaps, as you lie down tonight, you do not need to solve everything that is moving through your mind. Let those thoughts settle gently, like stardust, drifting through the vastness of space. The things that belong to the past can remain in the past. The things you do not yet understand can wait until tomorrow. You do not have to understand your entire story tonight. You do not have to know exactly who you will become. For now, it is enough to rest, to breathe slowly, to let the mind become quiet, and to remember that, just like the ancient stars above you. You are also carrying a history far deeper than what can be seen on the surface. Some parts of you may still be hidden, some may be waiting to emerge, some may be changing quietly, even while you sleep. So close your eyes, breathe in slowly, and breathe out gently. Let the night become still. Somewhere far beyond this room, ancient stars are continuing their long journeys through time, and perhaps, in the quiet darkness within you, something is also becoming ready to begin again. Good night. Sleep deeply, and let the universe carry the things you do not need to carry tonight. There are places in the universe that the human imagination is almost incapable of fully grasping. Not because they are too far away, but because what happens there lies far beyond our everyday experience. One such place exists inside a neutron star, the remaining core of some massive stars after they end their lives in violent gravitational collapse. From the outside, a neutron star may be only a few dozen kilometers across, yet within that tiny sphere can be contained more mass than the sun itself. Matter is compressed to astonishing densities, where the familiar rules of matter may give way to states that humans have never directly observed. And here, at the boundary between what is known and what remains hypothetical, we encounter a deeply Jungian question. What exists beneath the surface we are able to see? When astronomers observe a neutron star from a distance, they can only study the signals it sends outward. Its mass, radius, rotation rate, surface temperature, cooling rate over time, or changes in its orbital motion. If two neutron stars collide, gravitational waves can provide additional information about their internal structure. But no telescope can simply see through a neutron star and look directly into its core. We are like someone standing before a locked room, unable to open the door, yet still trying to understand what lies inside by listening to the sounds that emerge from it. This is where science begins to resemble an investigation rather than a simple act of observation. Physicists have proposed different models for matter at extremely high densities. Perhaps hyperons, particles containing strange quarks, exist deep inside neutron stars. Perhaps neutrons and protons are no longer the most appropriate way to describe matter in the deepest regions. Perhaps quarks become liberated from their usual structures and form a state known as quark matter. There are also possibilities involving condensates, superfluidity, and superconductivity. These words may sound unfamiliar, but behind them lies an incredibly simple question. When matter is compressed to an extreme limit, is it still what we would recognize as matter? Imagine taking a massive star and compressing most of its mass into a sphere only a few dozen kilometers across. Ordinary atoms can no longer maintain their familiar structures. Electrons are forced into extreme conditions. Protons and neutrons become components of an extraordinary environment. And the deeper we go, the less certain we become that our familiar concepts retain their usual meaning. This is where science encounters a fascinating boundary. We know that we do not know. Carl Gustav Jung wrote in Psychology and Alchemy, "The privilege of a lifetime is to become who you truly are." If we place these words beside the image of a neutron star, we can see a poetic parallel. A cosmic object cannot be understood merely through its surface, and neither can a human being. We often define ourselves through what can be seen: our profession, our roles, our personality, our successes, our failures, or the image we present to others. Yet beneath these layers lies a deeper world: memories, instincts, fears, desires, and unconscious aspects that sometimes even we ourselves do not understand. A neutron star reminds us that the surface is not the whole truth. One of the most fascinating possibilities is the existence of strange quark matter. In some theoretical models, matter composed of up, down, and strange quarks could become stable at extremely high densities. From this emerges the idea of strange stars, objects that might consist largely of strange quark matter rather than ordinary neutron matter. This remains a theoretical possibility, not an established fact. And that distinction is extremely important. Science does not turn an intriguing idea into truth simply because it is beautiful or plausible. It waits for evidence. It searches for observable signatures that can distinguish between competing models. What is the mass of a neutron star? How small is its radius? Does it cool quickly or slowly? When two neutron stars merge, how does the gravitational wave signal change? These questions are like small pieces of a puzzle collected from a room we cannot yet enter. And then there is an even stranger idea: quark nova. According to some hypothetical models, a neutron star could undergo a phase transition in which neutron matter changes into a state of quark matter. If this occurred under the right conditions, a powerful energetic event could follow the star's initial collapse, almost like a second explosion. But once again, we must keep our feet firmly on the ground. A quark nova has not been directly confirmed through observation. It remains at the boundary between theoretical physics and observational astrophysics. And it is precisely at such boundaries that human curiosity becomes most powerful, because perhaps what matters is not always finding the answer immediately. Sometimes the value lies in learning how to live with a question. Jung was deeply interested in the parts of the mind that cannot be fully seen through conscious awareness. He wrote in The Archetypes and the Collective Unconscious, "Until you make the unconscious conscious, it will direct your life, and you will call it fate." When we look at a neutron star, we are engaged in a somewhat similar process on a cosmic scale. We cannot directly see into its core, but what happens on the outside can reveal clues about what is happening within. A pulsar glitch, for example, can provide clues about how superfluid matter and vortices inside a neutron star interact with its crust. A very small change in its rotation rate can become evidence of a world of matter that humans cannot recreate in a laboratory. How strange that an object thousands of light years away can tell us something about the laws governing matter more deeply than almost anything we can create here on Earth. And as night falls, perhaps we do not need to solve these mysteries. Simply imagine a tiny sphere drifting through the darkness. Its exterior is cold and distant. Inside, matter is compressed under extreme conditions, and states of matter that we have only just begun to name may exist there. Hyperons, quark matter, condensates, superfluidity, superconducting states. These words still carry countless question marks, but perhaps that is the beauty of science. The universe has no obligation to be easy for us to understand. It simply exists, profound, complex, and mysterious. And human beings, with our small minds on a small planet, continue listening to faint signals from the darkness, trying to understand what lies beneath. And perhaps, in the moments before falling asleep, the image of a neutron star can become a gentle reminder to ourselves. Do not be too quick to conclude that you fully understand yourself simply because you have seen your outer layer. Beneath every human being are deeper layers waiting to be explored. Just as beneath a neutron star, there may exist an entire world that we still do not know how to name. Star systems, as Einstein's laboratories, in the quietness of the night sky, there are star systems moving according to laws so subtle that it can take humanity decades to recognize the story they are telling. They do not produce sounds that our ears can hear, nor do they need to create brilliant explosions to attract our attention. Simply by orbiting one another, slowly and steadily across millions of years, some stellar systems have become among the most remarkable natural laboratories the universe has ever given us. These are binary pulsar systems, containing two neutron stars bound together by gravity. And when we look at them through the lens of Carl Gustav Jung, They tell us not only a story about Einstein, gravity, and space-time, but also raise a deeper question. Can we understand something invisible by observing the traces it leaves behind? A pulsar is already an extraordinary object. It is a rapidly rotating neutron star with a powerful magnetic field that emits beams of radiation. When those beams sweep across Earth with each rotation, we receive pulses of signals with remarkable regularity. Some pulsars are extraordinarily stable, like natural clocks hidden in the depths of space. But when two pulsars, or a pulsar and another neutron star, exist together in a binary system, the story becomes much more fascinating. Two extremely dense objects orbit one another under the influence of an intense gravitational field. Their orbit is not completely unchanging. It evolves over time, and these tiny changes have provided one of the most elegant natural tests of Einstein's theory of general relativity in the history of science. In 1974, Russell Hulse and Joseph Taylor discovered the famous binary pulsar PSRB 1913+16, commonly known as the Hulse-Taylor pulsar. Long-term observations showed that the system's orbit was gradually shrinking in a way consistent with the prediction that the system was losing energy through gravitational radiation. This became one of the earliest important pieces of evidence supporting the existence of gravitational waves predicted by Einstein. The remarkable thing is that humanity did not need to directly see those waves at the time. We only needed to watch the rhythm of a star. A pulsar produces extraordinarily regular signals. If its orbit changes, the arrival times of those pulses on Earth also change. Tiny deviations, measured over many years, become traces of a process that cannot be seen with the naked eye. This is an idea deeply connected to Jungian depth psychology. In our inner lives, we rarely see directly the unconscious forces influencing us. Instead, we recognize them through dreams, emotional reactions, recurring choices, or behaviors that sometimes even we ourselves do not understand. Jung wrote in The Archetypes and the Collective Unconscious, "Until you make the unconscious conscious, it will direct your life, and you will call it fate." Perhaps the binary pulsar teaches us a similar principle. Invisible forces can be recognized through the visible traces they leave behind. If the Hulse-Taylor pulsar is a natural clock, then the double pulsar, the system PSRJ 737-3039 A, B, resembles an even more sophisticated laboratory. Both neutron stars are pulsars, meaning both emit observable signals. This allows astronomers to track the motion of two objects within an extremely strong gravitational field with remarkable precision. Here, relativistic effects become even more apparent. The orbit changes. The orientation of the orbit undergoes precession. The travel time of signals is affected by the gravitational field, and the system loses energy in precisely the general direction predicted by theory. No laboratory on Earth can easily create a system containing two objects with stellar masses compressed into spheres only a few dozen kilometers across, and then allow them to orbit one another within an intensely strong gravitational field. The universe has already created that experiment for us. We only need to be patient enough to read the results. What makes gravitational waves so remarkable is that they are not like light. They are disturbances that propagate through the very structure of space-time. When two compact objects orbit one another, energy can be carried away in the form of gravitational radiation. As energy is lost, their orbit changes. The two objects move closer together. Their orbital period changes. And eventually, if the system continues to evolve, they may merge in a violent event. It all begins with very small changes. And this makes us think about a paradox of life. Great changes do not always begin with great events. A small thought can change a decision. A decision can change a path. A small habit can change an entire life. The universe works in a similar way. A tiny amount of energy lost during each orbit may seem insignificant when viewed over a day or even a year, but accumulated over immense periods of time, it can completely transform the trajectory of an entire stellar system. Jung wrote in Psychological Types, "The greatest and most important problems of life are fundamentally insoluble." Perhaps this does not mean that we should stop searching for answers. Instead, it reminds us that some of the most important questions require patience, observation, and the ability to accept that our understanding will always have limits. Binary pulsars are precisely these kinds of questions. They do not speak to us in human language. They speak through the arrival time of each radio pulse, through tiny changes in their orbits, through the energy lost during each cycle, and through subtle distortions in space-time. We listen. Then, from those signals, we construct a picture of the universe. Perhaps the most astonishing thing is not simply that Einstein imagined space-time could curve, or that gravitational waves could exist. What is astonishing is that the universe actually leaves behind traces subtle enough for a civilization on a small planet to test those ideas. And tonight, as you lie down, try to imagine two neutron stars orbiting one another somewhere far away. They know nothing about Earth. They do not know that somewhere beneath a quiet night sky, a human being is looking upward and trying to understand them. They simply continue moving, slowly, steadily, according to laws that existed long before humanity appeared. Each orbit leaves behind a signal. Each tiny change carries information. Each gravitational wave is a whisper from space-time itself. And perhaps that is the gentlest lesson these stellar systems can offer us before we fall asleep. Not everything important needs to be loud. Sometimes, the deepest truth appears only in a small change that we are patient enough to notice. Far away in the endless darkness, two stars continue to orbit one another, and across distances of thousands, even millions of light years, they continue quietly telling us a story about time, gravity, and the very structure of reality. Invisible black holes and wandering black holes. There are things in the universe that do not shine, do not make sounds, and do not leave behind any obvious image that allows us to recognize them easily. They exist through their silence, and perhaps that is precisely what makes black holes so extraordinary. In the deep night, when the light outside the window gradually fades, and the mind begins to slow down, imagine that somewhere among the stars of the Milky Way, black holes are quietly drifting through space. They do not shine like stars, do not reflect light like planets, and without a companion star supplying them with matter, they can be almost invisible to ordinary telescopes. We can only know they exist when their gravity alters the world around them. And here, the story of invisible and wandering black holes begins to touch upon a profound question within the human mind. Does something truly need to be seen before we can consider it real? According to Carl Gustav Jung, much of our psychological life exists in a similar way. The deepest parts of ourselves often do not appear directly before consciousness. Instead, they reveal themselves through dreams, emotions, unexpected reactions, and fears, whose origins we sometimes do not understand ourselves. Jung wrote in The Archetypes and the Collective Unconscious, "Until you make the unconscious conscious, it will direct your life, and you will call it fate." Placed beside the image of an invisible black hole, these words become especially evocative, because both in the universe outside us and in the world within us, there are things that cannot be seen directly and yet can exert a powerful influence on everything around them. A stellar mass black hole can form after the death of a massive star. When its nuclear fuel is exhausted, the stellar core collapses under its own gravity. If the core is massive enough, that collapse can lead to the formation of a black hole. From the outside, the object seems to disappear from the story of light. But it has not disappeared from the universe. its gravitational field remains. It can pull on other objects, curve space-time, and influence the movements of nearby stars. There may be enormous numbers of such stellar mass black holes throughout our galaxy. Some exist in binary star systems, where matter from a companion star is drawn toward the black hole. As that material spirals around the black hole and becomes extremely hot, it can emit X-rays, unintentionally revealing the presence of the invisible predator. But what happens when a black hole has no companion star? Then the darkness becomes deeper. A solitary black hole may travel between the stars, leaving almost no direct evidence of its existence. It may once have belonged to a stellar system, perhaps created by the death of a massive star, and then received a gravitational kick during its formation that propelled it away from its original environment. Now, it wanders through the galaxy, carrying with it part of the history of a star that disappeared long ago. Yet, the universe is not completely helpless before darkness. One of the most subtle methods for searching for such black holes is gravitational microlensing. When a black hole passes close to the line of sight between us and a distant star, its gravitational field can bend the light coming from the background star. To an observer on Earth, the star may temporarily brighten or appear to shift position in a distinctive way. We do not see the black hole itself. We see the trace it leaves upon the light. This is beautiful when considered through the language of Jungian psychology. We, too, often fail to recognize the deepest parts of ourselves by looking directly at them. Instead, we observe the gravitational effects they create. Why does a small remark make us unusually angry? Why does a stranger make us feel strangely familiar? Why can a failure from many years ago still make our hearts ache? Perhaps what we see is only the light of consciousness being bent by something deeper beneath the surface. And then, in another mysterious region of the universe, astronomers search for an even more elusive type of black hole: intermediate mass black holes. These black holes are much more massive than those formed from individual stars, yet considerably smaller than the supermassive black holes found at the centers of many galaxies. They may range from hundreds to thousands of solar masses, and in some definitions may extend beyond that. Yet confirming their existence remains extraordinarily difficult. If stellar mass black holes are like tiny seeds, and supermassive black holes are like enormous ancient trees, intermediate mass black holes may represent a missing link that could help us understand how something small can eventually become something immense. How did the earliest black holes in the universe grow into monsters containing millions or billions of solar masses? Perhaps their history passed through stages that we still do not fully understand. Dense star clusters and certain unusual X-ray sources have become important places in this search. In such crowded environments, stars and compact objects frequently interact gravitationally. A black hole may accumulate matter, interact with other stars, or influence the structure of an entire stellar cluster. But once again, science must be patient. An unusual signal does not automatically become a confirmed discovery. Distance, motion, mass, and dynamical models all have to be examined carefully. This reminds us that the universe does not hand humanity its answers immediately. It leaves clues, and perhaps that is also how we should look at ourselves. Jung emphasized that discovering oneself is not a search for a perfect image, but a process of confronting the whole of who we are, including the parts we would rather hide. He wrote in Psychology and Alchemy, "One does not become enlightened by imagining figures of light, but by making the darkness conscious. In the darkness of tonight." Those words can be heard as a very gentle reminder. Not everything dark is frightening. Some regions of darkness are simply regions we have not yet understood. Wandering black holes are like that. They do not need light in order to exist. They exist through the structure of space-time around them, through the gravity they generate, and through the movements they quietly influence. Perhaps human beings are like that as well. The value of a life does not always lie in what other people can see. There are battles no one knows about, thoughts no one hears, and transformations that take place entirely within a person. Tonight, as you imagine a black hole quietly drifting among the stars, let that image become a gentle symbol. You do not need to understand everything happening inside your mind right now. You do not need to solve every question before falling asleep. The universe has existed for billions of years and still contains countless unanswered mysteries. Perhaps we are allowed to have unexplored regions of our own. Let the distant stars continue their journeys. Let invisible black holes quietly pass through the darkness. And in this moment, simply lie still and breathe more slowly, allowing your mind to rest. Because sometimes, the deepest understanding does not come from seeing everything, but from learning to be at peace with the things we cannot yet see. When black holes eat stars and swallow matter, there are moments in the universe when the life of a star does not end in a brilliant explosion, but through a slow, silent, and irresistible encounter with the power of gravity. Imagine, somewhere, in the cold emptiness of space, a star traveling along its orbit. It still carries light, heat, and the memory of millions or billions of years of evolution. But ahead, almost impossible to see, lies a black hole. The star moves closer. At first, nothing seems to change, but then gravity begins to affect it in an unusual way. The side closest to the black hole experiences a stronger gravitational pull than the side farther away. This difference, known as tidal force, gradually stretches and distorts the star until the structure that once held it together can no longer resist. In astronomy, this is known as a tidal disruption event, or TDE, one of the most violent and extraordinary phenomena we can observe from the distant universe. Seen through the lens of Carl Gustav Jung, a TDE can become a powerful image of what happens when a person comes too close to an unconscious force they have never recognized. In Jungian psychology, we are not shaped only by the things we consciously know about ourselves. Beneath consciousness exist memories, desires, fears, conflicts, and aspects of personality that have not yet been acknowledged. They may remain dormant for years until circumstances strong enough bring them to the surface. Jung wrote in The Archetypes and the Collective Unconscious, "Until you make the unconscious conscious, it will direct your life, and you will call it fate." Placed beside the image of a star being torn apart by a black hole, these words reveal a profound parallel. There are invisible forces that become visible only when they begin to alter the course of our lives. When a star approaches a black hole closely enough, it crosses a threshold beyond which its fate becomes almost impossible to reverse. Gravity does not simply pull the entire star inward all at once. It acts differently upon different parts of the star. The side closest to the black hole experiences a stronger force than the far side, causing the star to stretch into streams of matter. This process is often described by the vivid term spaghettification, referring to the way matter can be stretched into long, thin structures under the influence of extreme tidal forces. But what is remarkable is that the story does not end when the star is torn apart. Some of the stellar material may be flung outward or escape the system, while the rest begins moving around the black hole. That material does not immediately fall straight into darkness. It can form an accretion disk, a hot, rapidly rotating disk of matter surrounding the black hole. As layers of material collide, experience friction, and become compressed under extreme conditions, temperatures can rise enormously. The system can begin emitting intense radiation, particularly in the X-ray and ultraviolet wavelengths. And here lies the beautiful paradox of black holes. The black hole itself does not shine, yet the matter falling toward it can become one of the brightest sources we observe in the universe. Something that appears completely dark can be detected through the light produced by what it is consuming. Perhaps this also offers us a very human reflection. Sometimes, inner crises are not recognized directly. They reveal themselves through changes on the outside. Disturbed sleep, overwhelming emotions, reactions that seem disproportionate to an event, or a feeling of emptiness that we cannot quite name. In Jung's perspective, such manifestations can resemble the light from the mind's accretion disk, signs that a deeper process is unfolding beneath the surface. But a black hole cannot consume matter at an unlimited rate. When matter accumulates too rapidly, the radiation produced near the black hole can create pressure that pushes back against the inflowing material. This is part of the physics associated with the Eddington limit, the theoretical balance between gravity pulling matter inward and radiation pressure pushing outward. Yet the universe does not always operate under simple conditions. In some circumstances, matter may accrete at rates exceeding the Eddington limit, a state known as super-Eddington accretion. When this happens, the structure of the inflowing material, radiation, outflows, and geometry of the system can become far more complex. Such extreme states are particularly important when astronomers try to answer one of cosmology's great questions. How could supermassive black holes have reached millions or billions of solar masses within the relatively short history of the early universe? Perhaps ancient black holes experienced periods of extremely rapid feeding. Perhaps they grew from smaller seeds, continuously accumulating matter, merging with other black holes, and eventually becoming the enormous gravitational centers of galaxies. Tidal disruption events are not the only possible piece of this puzzle, but they allow us to witness, in a direct and dramatic way, one part of the ongoing relationship between black holes and matter. What makes a TDE especially remarkable is that it can transform a black hole that was previously almost invisible into a source of light that can be observed from billions of light years away. Astronomers can monitor how that light changes over time, study its radiation spectrum, and infer the environment surrounding the black hole. In this way, a destroyed star becomes a messenger. Its death allows humanity to detect something that, without that event, might have remained hidden in darkness. This is one of the deepest motifs we can find in nature. Sometimes, destruction makes the invisible visible. Jung once wrote in Psychology and Alchemy, "One does not become enlightened by imagining figures of light, but by making the darkness conscious." Perhaps these words are not only meant for the psychological journey, they can also become a gentle way of looking at the extreme phenomena of the universe. We often fear darkness because we do not know what lies within it. But science teaches us that darkness does not necessarily mean emptiness. It may contain structures, forces, and stories that we can recognize only through the traces they leave behind. A black hole consumes a star, and the light produced by that disrupted matter tells us the story of the black hole itself. A human being faces pain, and the emotions that emerge afterward can sometimes help them understand the deepest parts of themselves. So if there is something unresolved in your mind tonight, try to see it like a star standing before a region of darkness. You do not need to fight everything at once. You do not need to understand everything happening inside you. Simply observe. Simply breathe slowly, and allow the things that have not yet been given a name to exist within a moment of silence. In the universe, light from a TDE may take millions or even billions of years to reach Earth. It carries the story of a star that died long ago, yet only today are we able to hear that story. Perhaps the human mind works in a similar way. An emotion may have begun long before we recognized it. A dream may carry something that consciousness is not yet ready to name, and a part of our darkness does not necessarily need to be driven away. Sometimes, all it needs is to be seen. Now, allow the image of that distant star to slowly fade from your mind. The disk of matter continues to orbit the black hole. X-rays continue to travel silently across the emptiness of space. The universe continues moving that existed long before humanity appeared. And you, in this quiet room, do not need to do anything more. Simply lie down, breathe in slowly, breathe out gently, and let the questions about black holes, about dying stars, about darkness and light slowly drift away. Because sometimes, peace does not come from understanding all of the darkness. It comes from knowing that even within the deepest darkness, there is always a story unfolding. The battles between black holes. Close your eyes and imagine a region of space, millions, perhaps billions, of light years. There is no sound there that human ears could hear. No familiar sky. No ground beneath your feet. Only the profound darkness of space-time. And within that darkness, two black holes are orbiting one another. They do not immediately crash together. They may spend millions or billions of years moving toward their final moment. Two objects born from different stellar deaths are now bound together by a force of gravity so powerful that the space-time surrounding them becomes part of their dance. Seen through the lens of Carl Gustav Jung, this is not merely a story about the collision of two extreme objects. It also evokes a profound image of unconscious forces within the human mind. Some things may appear distant from one another, yet once they become bound together, they may spend a very long time moving toward an inevitable confrontation. During the early stages, the two black holes may orbit one another at a relatively large distance. Each black hole influences the other through its gravitational field. Together, they move around a common center, like two enormous shadows, engaged in a dance that humanity cannot directly see. But the system does not remain unchanged. As the black holes move, they emit gravitational waves, ripples that travel through the structure of space-time, carrying energy away from the system. As energy is lost, their orbit gradually shrinks. The distance between them becomes smaller. Their orbital speed increases, and as they draw closer, the process accelerates. There is something particularly fascinating about this story. Most of the battle unfolds extremely slowly, yet the final moment arrives almost in an instant on an astronomical timescale. The two black holes enter an increasingly violent gravitational spiral. Space-time becomes more strongly distorted. The gravitational waves grow more powerful. Eventually, the two event horizons no longer exist as separate boundaries. They merge into a single, larger black hole, heavier than either of its predecessors, continuing to vibrate before settling into a stable state. If we place this image beside Jungian psychology, we may recognize something familiar. Within a human being, deep conflicts rarely appear in a single moment. A fear, a wound, a desire, or a rejected part of the personality can exist quietly for years. It may orbit consciousness, sometimes at a distance, sometimes very close. Yet the longer it is avoided, the greater the internal tension may become. Jung wrote in The Archetypes and the Collective Unconscious, "Until you make the unconscious conscious, it will direct your life, and you will call it fate." Some inner battles do not need to be destroyed. They need to be recognized, brought into consciousness, and integrated. Two black holes cannot reconcile, in the human sense, of course. But the image of two separate objects ultimately becoming a single entity can evoke an important Jungian idea. Psychological maturity does not necessarily mean eliminating the opposing parts of ourselves. It can mean bringing them into a larger structure of wholeness. Jung called this movement towards psychological wholeness individuation. And then, on the 14th of September 2015, humanity directly detected a gravitational wave signal for the first time from the merger of two black holes. The event was designated GW150914. The signal lasted only a very brief period, yet it carried information about a merger that occurred approximately 1.3 billion light-years from Earth. Those two black holes completed their journey long before human beings knew they existed. Their gravitational waves traveled across the immense distance of space and eventually reached Earth. The extraordinary part is that humanity did not see those black holes with its eyes. We heard them by measuring incredibly tiny changes in spacetime. LIGO detected a signal so faint that the change in length measured by the instrument was far smaller than the size of a proton. Yet from such a tiny disturbance, scientists were able to reconstruct the story of two enormous objects colliding billions of light-years away. And here, the universe seems to offer humanity a very gentle lesson. The greatest things do not always produce the most obvious signs. A black hole merger can release an extraordinary amount of energy in the form of gravitational waves, equivalent to converting several suns' worth of mass into energy over an extremely short period. Yet by the time the signal reaches Earth, it is only a tiny ripple in a detector. An event of almost unimaginable scale can be recognized through an incredibly subtle movement. This is also true of psychological life. A profound transformation within a person may begin with something very small. A sentence, a dream, a moment of silence, a realization that we have spent too long living according to someone else's expectations. From the outside, such things may appear insignificant, but within us, they can be the gravitational wave of a much larger transformation. Jung wrote in 2 essays on analytical psychology, "The privilege of a lifetime is to become who you truly are." Perhaps this is where the story of two black holes becomes a story about being human. Not every transformation announces itself with a great sound. Some changes unfold quietly over many years before. One day, we realize that we have become someone different. But the story doesn't. When two supermassive black holes merge, the process can produce a strange phenomenon known as gravitational wave recoil. If the gravitational waves are emitted asymmetrically, momentum can be carried away in one direction, giving the newly formed black hole a recoil kick. Imagine an object with a mass millions or billions of times that of the Sun being pushed away from the center of the galaxy where it once resided. In extreme cases, that kick could theoretically be strong enough to displace the black hole from the center of its galaxy, or even eject it from the galaxy altogether if the recoil velocity exceeds the system's escape velocity. It is difficult not to feel overwhelmed by that image. An object massive enough to influence an entire galactic environment can itself be displaced from the very place that once seemed to be its center. And this brings us back to another deeply human lesson. Sometimes, what we believe is the center of our lives does not have to remain there forever. A relationship, a role, a career, a belief, or an image of ourselves may once have occupied the center of our existence. But life can create its own gravitational kicks, forcing the old structure to change. What is frightening is not always losing the old position. Sometimes, it is the opportunity to discover a new orbit. Tonight, in the darkness, let the image of two black holes slowly drawing closer become a gentle symbol. The conflicts within your mind do not need to be resolved tonight. The questions without answers can wait until tomorrow. You do not need to carry the entire weight of today into your sleep. The universe may take millions or billions of years to bring two black holes to their final moment of union. Some things within us need that much time, too. Breathe more slowly. Let your shoulders relax. Allow the thoughts circling inside your mind to gradually slow down, just as the newly merged black hole eventually settles after its final collision. Outside, gravitational waves continue traveling across the universe. Galaxies continue drifting through the darkness. Black holes continue moving according to laws that humanity has only begun to understand. And here, within the quiet of the night, You do not need to fight anything. Perhaps tomorrow will bring new questions. There may still be things we do not yet understand, but right now, you only need to allow yourself to rest. Because sometimes, peace does not mean that all conflicts have disappeared, but that we no longer need to run away from them. When a galaxy has two hearts, and when a star runs away, try to imagine a distant galaxy, where billions of stars drift silently through the darkness. From very far away, that galaxy might look like a peaceful river of light, a place where everything seems to move according to an unchanging order. But deep within it, an entirely different story may be unfolding. Two galaxies have collided and merged. Stellar structures have been stretched. Gas and dust have been disturbed. And at the centers of the two former galaxies, two supermassive black holes begin moving toward one another. For a period that may last millions of years, the newly formed galaxy may contain not one, but two gravitational hearts. And while those two enormous black holes slowly approach one another, some stars elsewhere may be drawn into a completely different kind of journey. They are hurled away at tremendous speeds, becoming hypervelocity stars fleeing from the very galaxy that gave them birth. Seen through the lens of Carl Gustav Jung, the image of two hearts within a single galaxy can become a beautiful symbol of the human mind. We often imagine that we have only one center, one unified ego, one clear story about who we are. But beneath consciousness, Jung believed that the human psyche is made up of many layers, many forces, and many different aspects of personality. There are things we know clearly about ourselves, but there are also parts that quietly exist within us. Parts we may never have truly confronted. Jung wrote in The Archetypes and the Collective Unconscious, until you make the unconscious conscious, it will direct your life, and you will call it fate. Perhaps a galaxy with two central black holes can become a symbolic image of a mind containing two different centers of gravity, two directions, two needs, two voices existing within the same human life. When two galaxies merge, the supermassive black holes at their centers do not necessarily collide immediately. At first, the distance between them may still be enormous, but as the merger progresses, both black holes can continue interacting with stars, gas, and the gravitational environment around them. If both are actively accreting matter, they may become active galactic nuclei, or AGN. In some cases, they can form what astronomers call a dual active galactic nucleus, a system containing two simultaneously active central regions. It is a strange image. A galaxy that appears to have a single heart may actually contain two enormous sources of energy shining at the same time. Some of these systems may represent an important stage before the two black holes eventually become a binary black hole. They remain gravitationally bound to one another, but their journey toward merger can take an extraordinarily long time. The universe does not hurry. Processes that humans describe as events are sometimes actually journeys lasting millions or hundreds of millions of years, and this makes us think about our own lives. There are changes we want to happen immediately. We want pain to disappear overnight. We want an answer to arrive instantly. We want to become a new person, simply because we have made a decision. But the human psyche does not always work that way. Some conflicts need time to be recognized. Some parts of ourselves need time to become integrated. And some questions can only be answered after we have lived with them long enough. Jung called the process of becoming a more whole person individuation. It is not about eliminating the contradictory parts of ourselves, but about learning to recognize and integrate them. A person can be strong and vulnerable at the same time. They can long for intimacy while fearing rejection. They can desire freedom while also longing to belong somewhere. These contradictions do not necessarily mean that something is wrong with us. Sometimes, they simply reveal that many different forces are existing within us at once. But the story of this section does not end with two black holes. Somewhere else in the galaxy, There are stars that are running away. Hypervelocity stars are stars traveling at extraordinarily high speeds, fast enough in some cases to escape the gravitational pull of the Milky Way. One possible mechanism for creating such stars involves gravitational interactions with Sagittarius A, the supermassive black hole at the center of the Milky Way. Imagine a binary star system approaching the central region of the galaxy. The two stars are moving around one another, bound together by gravity. But when the system comes too close to Sagittarius A, everything can become unstable. The enormous black hole can disrupt the binary system. One star may remain bound or have its orbit dramatically altered, while the other receives an enormous gravitational acceleration and is flung outward. A separation takes place in the darkness of the galaxy. There is no explosion, no farewell, only gravity deciding the outcome. The star that is thrown away may continue its journey for millions of years, carrying the memory of the moment when it came too close to one of the most extreme objects in the universe. Seen through Jungian eyes, the image of a star being expelled from the place where it was born can evoke a familiar archetype, the wanderer. In many myths, the hero must leave the familiar world before entering a new stage of growth. Leaving the place where we belong often brings loss, but sometimes that departure opens a trajectory that could never have been imagined before. Not every escape is a failure. Sometimes leaving an old orbit is necessary for an individual to discover a path of their own. Jung wrote in 2 essays on analytical psychology, "The privilege of a lifetime is to become who you truly are." A hypervelocity star does not choose its fate in the way a human being chooses, but its image can make us think about those moments in life when a powerful force compels us to leave a familiar environment. A career ends, a relationship changes, an old belief no longer fits. A version of ourselves that we once believed would last forever suddenly feels unfamiliar. At first, such a change may feel like a gravitational kick. We feel as though we have been pushed out of our familiar orbit. But with time, distance can allow us to see things that were impossible to recognize when we were too close. And remarkably, astronomers can use hypervelocity stars as dynamical traces. By studying their velocities, directions of motion, and chemical compositions, scientists can work backward to understand the gravitational interactions that occurred in the past. A star running away can become evidence of an event that humanity never witnessed directly. Once again, the universe reminds us that the past does not completely disappear. It leaves orbits. It leaves traces. It leaves movements that we can learn to read. The human mind works in much the same way. Past experiences may no longer be physically present, yet they can still leave traces in the way we love, fear, choose, and react. An unusually strong reaction may sometimes be the orbit of an old experience. A fear without an obvious origin may be the trace of something consciousness has forgotten but the unconscious still remembers. So tonight, instead of trying to solve everything inside your mind, simply observe it as astronomers observe the stars, without judgment, without rushing, simply watching. Somewhere very far away, 2 black holes are still moving toward one another in a galaxy that changed its shape long ago. Elsewhere, a star is racing through the darkness at a speed great enough to escape its galaxy. 2 stories that seem completely different, yet both are governed by gravity, by invisible forces that determine the trajectories of things we can see. And perhaps life is shaped by invisible forces as well. Memories, beliefs, fears, unspoken desires. But we do not necessarily have to be afraid of them, because once we begin to recognize them, they no longer remain entirely mysterious forces. Let this night move slowly. Imagine that you are looking at a galaxy from very far away. 2 small sources of light exist together at its center. Other stars continue moving. Some stars are leaving, and the entire galaxy continues its journey through the universe. You are on a journey too. You do not need to know exactly where tomorrow will take you. You do not need to know how your orbit will change. Right now, simply allow your body to rest. Breathe in slowly and breathe out gently. What happened today can remain with today. Tomorrow's questions can wait until tomorrow. For now, let your mind leave every tense orbit and drift into stillness. Because sometimes, just like a star moving through the vastness of space, we do not need to know the entire path ahead. We only need to keep moving and trust that somewhere within the darkness, there is still an orbit waiting to be discovered. The brief flashes of light from the deep universe. Try to imagine a very quiet night, when the sounds of the world have gradually faded away, and you are lying beneath a dark sky, looking up at the stars. The light visible to your eyes may appear motionless, but behind that stillness, the universe has never truly been silent. From regions hundreds of millions, even billions of light years away, a remarkably brief signal may suddenly cross the darkness. It may last only a few milliseconds, and then it disappears. These are called fast radio bursts, or FRBs, mysterious and powerful flashes of radio energy, almost like a sudden whisper emerging from the farthest reaches of space. What makes them so strange is not only how brief they are, but the enormous distances they have traveled to reach us. An FRB may have been produced at a time when Earth did not yet exist in anything resembling its present form, when distant stars and galaxies were still passing through completely different stages of cosmic history. And yet, after traveling for hundreds of millions or billions of years, a tiny pulse of radio energy can still reach telescopes here on Earth. For a few milliseconds, the distant past of the universe suddenly becomes a signal that human beings can hear. Seen through the lens of Carl Gustav Jung, FRBs evoke a beautiful image of things hidden beneath the surface. In depth psychology, Jung was deeply interested in aspects of the mind that do not clearly appear in consciousness but continue to influence us silently. The universe has its own unconscious regions as well. There are sources of light we have not directly observed, physical processes taking place in darkness, and hidden structures that occasionally leave behind a signal powerful enough to tell us something is happening there. One of the greatest mysteries surrounding FRBs is their origin. Some FRBs have been associated with magnetars, neutron stars possessing extraordinarily powerful magnetic fields. Imagine an object only about the size of a city, containing an enormous amount of matter, rotating through space at incredible speeds, and carrying an extraordinarily intense magnetic field. When its crust undergoes changes or experiences violent stresses, tremendous amounts of energy can be released in bursts of radiation. In such a moment, an object that seems tiny can send a powerful message across an immense cosmic distance. But what makes FRBs even more fascinating is that they do not tell us only about where they originated. Along their journey, the signal must pass through the thin material between galaxies. That interaction changes certain properties of the radio signal. Astronomers can study these changes to infer the amount of ionized matter lying between the source and Earth. In other words, a radio pulse lasting only a few milliseconds can help us map part of the cosmic web, the enormous network of matter stretching between galaxies. There is something profoundly Jungian about this. Something extraordinarily small can reveal something extraordinarily large. A signal that exists for only a moment can carry information about a journey lasting billions of years. And this reminds us that the value of something does not necessarily depend on how long it lasts. A moment can contain an entire story. A dream lasting only a few minutes can make us think for years. A very short sentence can change the way we see our lives. And a radio pulse, lasting only a few milliseconds, can help humanity understand more about the vast structure of the universe. Imagine a distant galaxy where billions of stars quietly drift through the darkness. From far away, that galaxy might look like a peaceful river of light, with everything moving according to an unchanging order. But deep inside, an entirely different story may be unfolding. Two galaxies have collided and merged. Their stellar structures have been stretched, gas and dust have been disturbed. And at the centers of the two former galaxies, two supermassive black holes are slowly moving toward each other. For a period that may last millions of years, the newly formed galaxy may contain not one, but two gravitational hearts. And while these two enormous black holes gradually approach one another, some stars elsewhere may be pulled into an entirely different kind of journey. They can be accelerated to tremendous speeds, becoming hypervelocity stars, stars fleeing from the very galaxy that gave them birth. Seen through the lens of Carl Gustav Jung, the image of two hearts within a single galaxy can become a beautiful metaphor for the human mind. We often imagine ourselves as having a single center, one unified ego, one clear story about who we are. But beneath consciousness, Jung believed that the human psyche is composed of many layers, forces, and different aspects of personality. There are things we know clearly about ourselves, but there are also parts that quietly exist within us, waiting to be recognized. Jung wrote in The Archetypes and the Collective Unconscious, "Until you make the unconscious conscious, it will direct your life and you will call it fate." Perhaps a galaxy with two central black holes can become a symbolic image of a mind containing two different centers of gravity, two directions, two needs, two voices existing within a single human life. When two galaxies merge, their supermassive black holes do not necessarily collide immediately. The distance between them may initially remain enormous, but as the merger evolves, both black holes can continue interacting with stars, gas, and the gravitational environment around them. If both are actively accreting matter, they may become active galactic nuclei, or ANN. In some cases, they can form a dual active galactic nucleus, a system containing two simultaneously active central regions. It is a strange image. A galaxy that appears to have a single heart may actually contain two enormous sources of energy shining at the same time. Some of these systems may represent an important stage before the two black holes eventually become a binary black hole. They remain gravitationally bound to one another, but their journey toward merger can take an extraordinarily long time. The universe is not in a hurry. Processes that humans describe as events are sometimes actually journeys lasting millions or even hundreds of millions of years. And this makes us think about our own lives. There are changes we want to happen immediately. We want pain to disappear overnight. We want an answer right away. We want to become a new person simply because we have made a single decision. But the human psyche rarely works that way. Some conflicts need time to be recognized. Some parts of ourselves need time to be integrated. And some questions can only be answered after we have lived with them long enough. Jung called the process of becoming a more complete human being individuation. It is not about eliminating the contradictory parts of ourselves. It is about learning to recognize and integrate them. A person can be both strong and vulnerable. They can long for closeness while fearing rejection. They can crave freedom while also wanting to belong somewhere. These contradictions do not necessarily mean that something is wrong with us. Sometimes, they simply reveal that many forces are living within us at the same time. But the story of this galaxy does not end with two black holes. Somewhere else in the galaxy, there are stars that are running away. Hypervelocity stars are stars moving at extraordinarily high speeds. In some cases, they can travel fast enough to escape the gravitational pull of the Milky Way. One possible mechanism for creating such stars involves interactions with Sagittarius A, the supermassive black hole at the center of our Milky Way. Imagine a binary star system moving too close to the galactic center. The two stars are orbiting one another, held together by gravity. But as the system approaches Sagittarius A, everything becomes unstable. The enormous black hole can disrupt the binary system. One star may remain bound or have its orbit dramatically altered, while the other receives an enormous gravitational acceleration and is flung outward. A separation takes place in the darkness of the galaxy. There is no explosion, no farewell, only gravity deciding their fate. The expelled star may continue its journey for millions of years, carrying with it the memory of the moment when it came too close to one of the most extreme objects in the universe. Through Jungian eyes, the image of a star being pushed away from its birthplace can evoke a familiar archetype, the traveler. In many myths, the hero must leave the familiar world before entering a new stage of growth. Leaving the place where we belong often carries a sense of loss, but sometimes that departure opens a trajectory we could never have imagined before. Not every escape is a failure. Sometimes, leaving an old orbit is necessary for an individual to discover a path of their own. Jung wrote in 2 essays on analytical psychology, "The privilege of a lifetime is to become who you truly are." A hypervelocity star does not choose its destiny in the way human beings choose theirs, but its image can make us think about those moments in life when a powerful force pushes us out of a familiar environment. A job ends, a relationship changes, an old belief no longer fits. A version of ourselves that we once believed would last forever suddenly feels unfamiliar. At first, that change may feel like a gravitational kick. We feel as though we have been thrown out of our familiar orbit. But with time, distance can allow us to see things that were impossible to recognize when we were too close. And what is beautiful is that astronomers can use hypervelocity stars as dynamical traces. By studying their velocities, directions, and compositions, scientists can reconstruct the gravitational interactions that may have occurred in the past. A fleeing star can become evidence of an event that humanity could never directly witness. Once again, the universe reminds us that the past does not completely disappear. It leaves an orbit. It leaves a trace. It leaves movements that we can learn to read. The human mind works in much the same way. Past experiences may no longer be physically present, but they can continue to shape the way we love, fear, choose, and react. An unusually strong reaction may be the orbit of an old experience. A fear whose origin we cannot explain may be the trace of something consciousness has forgotten, while the unconscious still remembers. So tonight, instead of trying to solve everything inside your mind, simply observe it the way an astronomer observes distant stars. Without judgment, without rushing, simply watch. Somewhere far away, 2 black holes are still moving toward one another inside a galaxy that has already been transformed. Somewhere else, a star is racing through the darkness fast enough to escape its galaxy. 2 stories that seem completely different, yet both are governed by gravity, by invisible forces that determine the paths of things we can see. And perhaps our lives are shaped by invisible forces as well. Memories, beliefs, fears, desires that have never been given a name. But we do not necessarily have to fear them, because once we begin to recognize them, they no longer remain completely mysterious forces. Let the night move slowly. Imagine that you are looking at a galaxy from an immense distance. 2 small sources of light exist together at its center. Other stars continue their journeys. Some stars are leaving, and the entire galaxy continues moving through the universe. You are on a journey too. You do not need to know exactly where tomorrow will take you. You do not need to know how your orbit will change. Right now, simply allow your body to rest. Take a slow breath in and breathe out gently. Whatever happened today can remain with today. Tomorrow's questions can wait until tomorrow. For now, let your mind leave every stressful orbit and drift into stillness. Because sometimes, just like a star moving through the vastness of space, we do not need to know the entire path ahead. We only need to keep moving and trust that somewhere in the darkness, there is an orbit waiting to be discovered. The mysterious flashes from the deep universe. Imagine a quiet night when the sounds of the world gradually fade away, and you lie beneath a dark sky, looking up at the stars. The stars may appear still, distant, and peaceful, But behind that apparent silence, the universe has never truly been quiet. Across distances of hundreds of millions, or even billions, of light years, stars are being born, aging, and collapsing. Objects so dense that even light struggles to escape are moving through violent gravitational dances. And sometimes, in a matter of just a few seconds, one of the most powerful events we have ever observed suddenly erupts: a gamma-ray burst. What makes these events so strange is not simply how powerful they are, but how briefly some of them can last. Certain gamma-ray bursts exist for only a very short time. Yet during that brief moment, they can release an extraordinary amount of energy. Gamma rays occupy the highest energy portion of the electromagnetic spectrum, and they can emerge from some of the most extreme environments in the universe. Some gamma-ray bursts are associated with the collapse of massive stars. Others occur when compact objects, such as neutron stars, merge with one another. And if one of these relativistic jets happens to be pointed toward Earth, we may observe it as an incredibly powerful flash from billions of light-years away. Seen through the lens of Carl Gustav Jung, a gamma-ray burst can become a powerful image of what happens when a structure can no longer maintain its former state. In depth psychology, human beings often try to keep the outer world stable while countless movements continue beneath the surface. There may be pressures accumulating for years without our awareness. There may be changes taking place slowly, until eventually the old structure can no longer hold itself together. A massive star has its own history. For most of its life, a star maintains a delicate balance between gravity pulling matter inward and the energy generated within it pushing outward. But as its available fuel gradually becomes exhausted, that balance can collapse. The stellar core contracts under its own weight. In some cases, this collapse can lead to the formation of a black hole or another compact object, while simultaneously producing extremely fast streams of matter known as relativistic jets. Imagine a star many times more massive than our Sun, a star that has existed for millions of years, finally reaching its decisive moment. Its outer layers can no longer remain in their familiar state. At the center, an incredibly dense object forms. Around it, matter may create an accretion disk, spinning at tremendous speeds. From the polar regions of the system, jets may be launched at velocities approaching the speed of light. And if such a jet is directed toward us, the story of a dying star in a distant galaxy suddenly becomes a signal humanity can detect. It is strange. An event taking place somewhere we can never reach, surrounding an object we can never touch, can still leave a signature on instruments billions of light-years away. Jung once wrote in The Archetypes and the Collective Unconscious, "The meeting with oneself is, at first, the meeting with one's own shadow." When we think about extreme cosmic explosions, this quote can evoke a deeper connection. Sometimes what frightens us most is not chaos itself, but the parts of reality we do not yet understand. The universe has its own shadow extreme environments, unexplained phenomena, and energies far beyond human intuition. But gamma-ray bursts are more than spectacular cosmic explosions. They can also serve as cosmic clocks. Their duration, radiation characteristics, and surrounding environments can help astronomers investigate their origins. In particular, short gamma-ray bursts reveal another extraordinary story. They are often associated with mergers involving compact objects, such as two neutron stars. Imagine two objects that were once the remnants of ancient stars, drifting through the universe until gravity gradually draws them together. They begin orbiting one another. With every orbit, they move closer. Energy escapes in the form of gravitational waves, ripples traveling through the very fabric of space-time. Then comes the final moment. The two neutron stars collide. A merger takes place, and only a very short time later, a gamma-ray burst is detected. The event of 2017, widely known through the signals GW170817 and gamma-ray burst GRB170817A, became one of the remarkable moments in modern astronomy. Gravitational waves were detected from the neutron star merger, and less than 2 seconds later, a gamma-ray burst was observed. Telescopes on Earth and in space then continued following the changing source of light. What made this event so extraordinary was that humanity was no longer simply seeing the universe through light. We were beginning to hear it through gravitational waves. We could observe it through gamma rays. We could study it through optical light, X-rays, infrared radiation, and many other forms of information. This is the spirit of multi-messenger astronomy. A single cosmic event can tell its story through several different physical languages. Gravitational waves reveal the motion of extremely massive objects. Gamma rays reveal high-energy processes. Light from a kilonova can tell us about newly created matter and how it decays. Just as a human being cannot be understood through a single moment, the universe cannot be understood through only one kind of signal. Perhaps this is the most beautiful lesson these extreme cosmic events can offer us before sleep. In life, we often fear moments of transformation. We fear a door closing, a relationship ending, a familiar chapter disappearing. But when we look at the stars, we see that an ending does not always mean disappearance. A star can die, yet its death may create new matter. A merger can end the lives of 2 neutron stars, yet at the same time create an event that humanity will only discover billions of years later. Jung once wrote in Psychology and Alchemy, "In the darkness of the night, the light of the day is born." Perhaps the universe is telling the same story in its own language. An explosion can begin with collapse. Collapse can create a new object. A merger can create new elements. And a signal released in only a few seconds can travel across billions of light years to reach us. So tonight, as you prepare to drift into sleep, imagine a region of space very far away. 2 neutron stars are moving closer together. They circle one another in silence. There is no explosion that human ears can hear. No sound can travel through the vacuum of space. Only space-time itself trembles ever so slightly as these extreme objects approach their final moment. Then they merge. A beam of gamma rays races outward. Gravitational waves continue spreading through space. A kilonova begins to glow. And billions of years later, those signals arrive here on Earth. For one brief moment, the distant past of the universe touches our present. You do not need to understand every equation to feel the wonder of it. Simply lie still, take a slow breath, and imagine that above you is a universe so vast that no human mind could ever fully measure it. The most violent explosions are still taking place somewhere far away. Ripples are still traveling through space-time. Photons are still continuing their journeys. And you, right now, can simply become still. Because among all those enormous cosmic movements, there is something wonderfully gentle. The universe may be unimaginably violent, but the moment you lie quietly beneath the night sky can still be completely peaceful. Kilonova and the cosmic factories that create heavy elements. There are things in the universe that seem to be born from chaos. A star dies. 2 massive objects crash into one another. Space-time trembles. Light suddenly erupts and then slowly fades away. If we look at such an event only through human eyes, we might call it destruction. But when we look deeper, through the lens of Carl Gustav Jung, we may recognize something else. Sometimes destruction is simply the outward form of a much deeper process of transformation. And in some of the most violent places in the universe, one of those extraordinary transformations is taking place: the creation of heavy elements, including gold, platinum, and many other rare elements. This is the story of the kilonova, a colossal cosmic element factory that can light up after the merger of neutron stars. Imagine 2 neutron stars drifting through the darkness. They are no longer stars burning like our Sunday. They are incredibly dense remnants of stars that have already died, where an enormous amount of mass has been compressed into a volume only a few dozen kilometers across. These 2 objects may orbit one another for a very long time, With every revolution, they move slightly closer. Energy is carried away by gravitational waves. Their orbit gradually shrinks until the distance between them is no longer enough to sustain their delicate cosmic dance. Then they merge. In that moment, matter is compressed, stretched, and thrown outward. Some of the material is expelled from the system in streams rich in neutrons, and this is where another story begins. It is no longer simply the story of two stars dying. It becomes the story of elements being born. One of the most important mechanisms scientists study is the rapid neutron capture process, or R process. In the neutron-rich environment created by the merger, atomic nuclei can capture neutrons extremely rapidly. Before those nuclei have time to undergo radioactive decay, through a series of extraordinarily complex processes, heavy atomic nuclei can be created. This is one of the important pathways that helps scientists understand the cosmic origin of many of the universe's heaviest elements. Gold that we hold in our hands, platinum used in countless technologies and industries, the elements belonging to the lanthanide group, all of them may have a cosmic history far deeper than their peaceful appearance suggests. A particle of matter inside the ring you are wearing may once have passed through an extreme event that occurred long before Earth existed. It may once have been part of an ancient star, or been created during a neutron-star merger billions of years ago. After countless transformations, that material eventually became part of a planet, a piece of rock, a piece of jewelry, and perhaps one day, it came to rest quietly in the palm of a human hand. This is what makes the story of the kilonova so gentle when we contemplate it before sleep. Because we often think of ourselves as separate beings. I have my body. You have your life. A star exists somewhere far away. A planet exists somewhere else. But matter does not preserve those boundaries forever. It travels. It transforms. It is recycled through different generations of stars and planets. Jung once wrote in The Archetypes and the Collective Unconscious, "The privilege of a lifetime is to become who you truly are." That idea can open the door to a beautiful way of thinking about transformation. In Jung's depth psychology, growth is not simply about becoming an entirely different person. It is the process of going deeper into ourselves, facing the hidden parts of our psyche, and gradually integrating them into a new whole. The universe seems to have its own form of transformation. A star no longer exists as it once did, but its matter continues its journey. Two neutron stars are no longer two separate stars. Yet, their merger creates an entirely new environment, and within that environment, new elements can emerge. That is the deeper beauty of the kilonova. After the merger, the expelled material does not simply disappear. Radioactive nuclei within the newly formed matter continue to decay. That radioactive decay releases energy, heating the material and producing light that we can observe. This glow creates the kilonova, a brief but extraordinary phenomenon that carries information about physical processes taking place in an environment humanity could never reproduce on Earth. The light of a kilonova does not remain unchanged. It evolves over time. Its color, brightness, and spectrum can help astronomers infer the composition of the material that was expelled. Heavy elements, especially those that strongly absorb light, can influence how radiation escapes from the expanding cloud of material. And so, a collision becomes a laboratory with no doors, no laboratory tables, no scientists standing beside it. Only extreme objects and light traveling across space to tell us what happened. This is where science and contemplation can meet. Jung once wrote in Psychology and Alchemy, "In the darkness of the night, the light of the day is born." In the context of a kilonova, the image becomes especially evocative. From a violent merger, light emerges. From matter torn apart, new elements are created. From the ending of two neutron stars, ingredients that may one day become part of future worlds are released. Destruction and creation do not always stand on opposite sides. Sometimes, they are two stages of the same process. And this can also be true of the human mind. There are periods in life when we feel that everything is falling apart. An old belief no longer fits. An image of ourselves collapses. A path that once seemed certain suddenly becomes unclear. In those moments, it is easy to believe that we are simply losing something. But Jung described deep psychological development as a process of individuation, the movement toward becoming a more complete whole, in which different parts of the psyche are gradually recognized and integrated. And perhaps the universe reminds us that transformation does not always look beautiful in the beginning. Look at a kilonova. There is nothing gentle about the initial merger. Two extreme objects crash into one another. Space-time trembles. Matter is compressed and expelled. Radiation is released. But after all that violence, new elements are created. Something can emerge from an event that initially looks like an ending. And perhaps the most remarkable part is that the story does not end when the kilonova fades. The expelled material can eventually mix with the interstellar medium. Over immense periods of time, it may become part of clouds of matter, new generations of stars, and new planetary systems. A merger that occurred billions of years ago may contribute to the material that eventually forms a world long after the original event has disappeared. That makes the concept of time seem almost incredibly small. A kilonova may last only a brief moment in cosmic history, but the elements it creates can exist for unimaginably longer periods. And perhaps this is a gentle reminder for us before we fall asleep tonight. Not everything valuable needs to last forever to have meaning. A single moment can create consequences that continue for billions of years. A brief encounter can change an entire life. A painful ending can become the beginning of something that did not yet have a name. And sometimes, what feels like the collapse of an old world is simply the universe and perhaps the deepest parts of ourselves making room for something new. So tonight, if there is something in your life that feels unfinished, broken, or uncertain, you do not have to understand it all. You do not have to know what it will become. The universe itself does not reveal the final form of matter in a single moment. It takes stars, explosions, collisions, time, and countless transformations to create something as simple as a piece of gold resting quietly in a human hand. Perhaps we are not so different. We, too, are made through transformation, through endings, through beginnings, through things we lose and things we carry forward. So let your thoughts become quiet now. Imagine the distant glow of a kilonova fading across the darkness. The neutron stars are gone. The light is slowly disappearing, but the elements they created continue traveling through the universe. Somewhere, someday, they may become part of a new star, a new planet, a new world, perhaps even something held gently in someone's hand. And for tonight, that is enough. You do not need to know what every ending will create. You only need to rest. Breathe in slowly and breathe out gently. Let the worries of today drift away, because sometimes, just like the universe itself, we are not falling apart. We are becoming something new. Supernovae and the cosmic factories that forge heavy elements. There are things in the universe that seem to be born from chaos. A star dies. Two massive objects collide. Space-time trembles. Light erupts, and then gradually fades away. If we look only through human eyes, we might call it destruction. But when we look deeper, through the lens of Carl Gustav Jung, perhaps we can recognize something else. Sometimes destruction is only the outer form of a much deeper process of transformation. And in some of the most violent places in the universe, one of those extraordinary transformations is taking place. The creation of heavy elements, including gold, platinum, and many other rare and precious elements. This is the story of the kilonova. Enormous cosmic element factories that can shine after the merger of neutron stars. Imagine two neutron stars drifting through the darkness. They are no longer stars burning like our Sunday. They are incredibly dense remnants of dead stars, where enormous amounts of matter are compressed into objects only a few dozen kilometers across. These two objects may orbit one another for a very long time. With every orbit, they move slightly closer. Energy is carried away by gravitational waves. Their orbit gradually shrinks until the distance between them is no longer enough to sustain their delicate cosmic dance. And then they merge. In that moment, matter is compressed, stretched, and thrown outward. Some of it escapes the system in streams of neutron-rich material, and this is where another story begins. It is no longer simply the story of the death of two stars. It becomes the story of the birth of elements. One of the important mechanisms scientists study is the rapid neutron capture process, or the R process. In the neutron-rich environment created by a merger, atomic nuclei can capture neutrons extremely rapidly. Before those nuclei have time to undergo radioactive decay, through a complicated chain of processes, heavy nuclei can form. This is one of the major pathways scientists use to understand the origins of many of the universe's heaviest elements. The gold we hold in our hands, the platinum used in countless applications, the lanthanides and other heavy elements, all of them have a cosmic history far deeper than their quiet appearance suggests. A particle of matter inside a ring you wear may have passed through an extreme event that happened long before Earth existed. It may once have been part of an ancient star, or been created in a neutron-star merger billions of years ago. After countless transformations, that material may eventually become part of a planet, a rock, a piece of jewelry, and one day rest quietly in the hand of a human being. This is what makes the story of the kilonova so beautiful to contemplate before sleep, because we often think of ourselves as separate individuals. I have my body, you have your life. A star exists somewhere far away, a planet exists somewhere else. But matter does not preserve those boundaries forever. It moves, it changes, it is recycled through different generations of stars and planets. Jung wrote in The Archetypes and the Collective Unconscious, "The privilege of a lifetime is to become who you truly are." That idea can open the door to a beautiful way of understanding transformation. In Jungian depth psychology, growth is not simply about becoming an entirely different person. It is about going deeper into ourselves, confronting the hidden parts of our psyche, and integrating them into a new whole. The universe seems to have its own form of transformation. A star no longer exists as it once did, but its matter continues its journey. Two neutron stars are no longer two separate stars, but their merger creates a new environment, and from that environment, new elements can emerge. That is the deeper beauty of the kilonova. After the merger, the ejected material does not simply disappear. Radioactive nuclei within the newly formed material continue to decay. This radioactive decay releases energy, heating the material and producing light that we can observe. That glow is what creates a kilonova, a brief phenomenon carrying information about physical processes occurring in an environment that human beings could never reproduce on Earth. The light from a kilonova also changes with time. Its color, brightness, and spectrum can help astronomers infer the composition of the expanding material. Heavy elements, particularly those that strongly absorb light, can influence how radiation escapes from the expanding cloud. And so, a collision becomes a laboratory with no doors, no tables, no scientists standing beside it, only extreme objects and light traveling through space, telling their story. This is where science and contemplation can meet. Jung wrote in Psychology and Alchemy, "In the darkness of the night, the light of the day is born." In the context of a kilonova, that image becomes especially powerful. From a violent merger, light emerges. From matter torn apart, new elements are created. From the ending of two neutron stars, the ingredients that may eventually become part of future worlds are released. Destruction and creation are not always opposites. Sometimes they are two stages of the same process, and the same idea can be applied to the human mind. There are periods in life when we feel as though everything is falling apart, An old belief no longer feels right. An image of ourselves collapses. A path that once seemed certain suddenly becomes unclear. In those moments, it is easy to believe that we are simply losing something. But Jung described profound psychological development as a process of individuation, a movement toward wholeness in which different parts of the psyche gradually become recognized and integrated. And perhaps the universe reminds us that transformation does not always look beautiful in the beginning. Look at a kilonova. There is nothing gentle about the initial merger. Two extreme objects crash together. Space-time trembles. Matter is compressed and expelled. Radiation is released. But after all that violence, new elements are created. Something can emerge from an event that initially looks like an ending. And the story does not stop when the kilonova fades. The material ejected into space can eventually mix with the interstellar medium. Over immense periods of time, it may become part of clouds of matter, new generations of stars, and new planetary systems. A merger that occurred billions of years ago may contribute to the material that eventually forms a world long after the original event has disappeared from view. That makes the concept of time feel very small. A kilonova may be only a brief moment in cosmic history, but the elements it creates can survive for far longer. And perhaps this is also a gentle reminder for us before we fall asleep. Not everything that matters has to last a long time in order to have meaning. A single moment can create consequences that continue for billions of years. A meeting can change an entire life. A loss can open the door to a new way of seeing. An ending can become the raw material for a beginning we cannot yet see. So tonight, as you close your eyes, imagine two neutron stars somewhere very far away. They are moving closer together through the darkness. No one on Earth knows that this moment is happening. Then they merge. Space trembles. Neutron-rich matter is thrown outward. New nuclei begin to form. A kilonova flashes into existence. Then the light slowly fades. But the story of the matter continues. Perhaps billions of years later, a small part of that material will rest on a planet. Perhaps it will become a stone, a piece of jewelry, or simply a grain of dust drifting through space. And perhaps, somewhere, a conscious being will look at it and wonder, where did I come from? The answer may lie farther away than any memory we have ever possessed. Because before we became human, before Earth existed, before the sun was born, the matter that makes up our bodies had already begun a very long journey. And somewhere along that journey, stars may have died so that we could one day exist. So tonight, let the night become completely quiet. You do not need to solve every question in your life. You do not need to understand the entire universe. Just remember that in a vast universe, everything is continually transforming. Stars die, elements are born, new worlds take shape. And we, these small and fragile beings lying beneath the night sky, are simply one tiny part of that immense flow. From the ending of a star, the universe creates the material for a new world. Perhaps sometimes, an ending within ourselves is also quietly preparing the shape of another beginning. Now let your shoulders relax. Take a slow breath in and breathe out. Out there, the universe continues on its journey, and you can rest. The strangest galaxies in the universe. There are places in the universe that amaze us not because they are the brightest, the largest, or the most violent, but because they seem to defy our familiar ideas of what a galaxy should look like. When we close our eyes and imagine a galaxy, perhaps we picture an enormous structure containing billions of stars, glowing spiral arms, and vast clouds of gas and dust stretching through the darkness. But the universe contains far more than these familiar shapes. There are galaxies that are enormous, yet almost empty. There are tiny galaxies forming stars at astonishing rates. There are galaxies shaped like rings. There are galaxies with rings of material rotating almost perpendicular to their main disks. And there are galaxies that appear to be stretched into long, tentacle-like structures drifting through space. Within this extraordinary diversity, we begin to recognize something that resonates with the way Carl Gustav Jung viewed the human mind. What is unusual is not necessarily what is wrong. Sometimes, unusual forms reveal deeper layers that an ordinary appearance could never show us. Let us begin slowly with ultra-diffuse galaxies, galaxies that can be relatively large in size but contain very few stars. From far away, they may look like faint ghosts drifting through space. They are not completely empty, but their stellar density can be so low that their light becomes extremely diffuse and difficult to detect. The strange thing is the contrast. A structure can be enormous and yet give an almost empty impression. Through a Jungian lens, this raises a very human question. Can something be vast without needing to express itself loudly? In depth psychology, we often make the mistake of equating value with what can be seen. A noisy mind filled with thoughts, achievements, and activity may seem richer than a quiet mind. But sometimes emptiness is also part of the structure. Silence does not necessarily mean absence. Then we encounter green pea galaxies, small, compact galaxies with a distinctive green appearance caused by strong emission from regions containing young, newly formed stars. They can be far smaller than the galaxies we are accustomed to seeing. Yet inside them, something extraordinary is happening. New generations of stars are being born at remarkable rates. Imagine a small room containing an intense source of energy burning brightly inside it. Space does not completely determine vitality. Something small can still contain an extraordinary process of creation. This resembles the quiet movements within the human soul. There are periods when we believe we are standing still, while deep beneath the surface, a process of reorganization is taking place. A new idea, a new realization, or a forgotten part of ourselves may be beginning to emerge. Jung wrote in The Archetypes and the Collective Unconscious, "The privilege of a lifetime is to become who you truly are." Perhaps growth is like star formation. Sometimes the most important process occurs before the first light can even be seen. But the universe contains galaxies whose forms seem almost as though they came from a dream. Ring galaxies can form after unusual gravitational interactions. When one galaxy passes through or strongly affects another, such an interaction can create a density wave, moving through the galaxy's disk and trigger regions of intense star formation. A structure that was once stable can be disrupted, and from that disruption, a new shape can emerge. If we looked only at the moment of collision, we might call it destruction. But if we observe it across hundreds of millions of years, it becomes a stage of transformation. This is closely connected to Jung's idea of transformation. In our inner lives, an event that leaves us disoriented is not necessarily the end. It may break apart an old structure and allow new possibilities to emerge. Jung wrote, "There is no coming to consciousness without pain." This does not need to be understood as a celebration of suffering. It can simply be a gentle reminder that profound change often requires us to look directly at the things that once made us uncomfortable. Like a galaxy after a gravitational encounter, sometimes a person needs to be shifted before they can discover a new shape within themselves. Farther away, we encounter polar ring galaxies. Galaxies containing a ring of material and stars rotating almost perpendicular to the plane of the main galaxy. They are fascinating because their structure seems some of this material may have been acquired from another galaxy or formed through complex interactions in the distant past. Looking at such a system, we see that the universe does not always organize itself according to a simple plane. Things that appear contradictory can sometimes coexist. And this brings us to the shadow in Jungian psychology. Human beings often want to construct a consistent image of themselves. I am this kind of person. I am not that kind of person. But the actual mind is far more complicated. The rejected parts of ourselves, the emotions we do not want to acknowledge, and the desires we once pushed aside can continue to exist. Jung wrote, "The shadow is a moral problem that challenges the whole ego personality. When we become calm enough to look at that shadow, it does not necessarily become an enemy. It can become a source of information that helps us understand ourselves more deeply. Then there are compact elliptical galaxies, small, dense galaxies that may represent surviving cores after a larger galaxy has lost much of its outer structure through powerful gravitational interactions. Imagine a structure that was once enormous, stretching across space, gradually losing its outer layers until only a dense core remains. There is something quietly beautiful about this image, because sometimes loss does not only take things away, it also reveals the core. There are periods in our lives when we experience something similar. A relationship ends. A job disappears. An old belief collapses. At first, all we can feel is how much we have lost. But after the familiar outer layers fall away, we may begin to discover what truly belongs to us. In Psychological Types, Jung wrote, "The privilege of a lifetime is to become who you truly are." That journey is sometimes not about adding more. Sometimes it is about removing what we no longer need. And then, in the darkness between galaxies, we encounter one of the most beautiful images of all: jellyfish galaxies. When a galaxy travels through the hot, dense environment of a galaxy cluster, ram pressure can strip gas away from it. Those tails are not merely signs of loss. They can contain regions where new stars are forming, places where material stripped from the parent galaxy continues to transform. Once again, the universe reminds us that the boundary between losing something and beginning again can be incredibly thin. And finally, let our gaze rest upon relic galaxies, galaxies that may contain populations of very old stars and preserve clues about galaxy formation in the early universe. They are like enormous cosmic time capsules. When their light reaches us, it does not simply tell us about where they are. It tells us about an era that has already passed. Perhaps this is the most beautiful thing about looking at strange galaxies. They do not merely help us understand how the universe works. They also reflect something profound about ourselves. We too contain bright places, dark places, empty spaces, periods of chaos, and ancient memories buried deep within us. There are parts of ourselves that seem to have disappeared but still quietly influence the present. There are wounds that once caused an old structure to collapse, only to reveal an entirely new shape afterward. And as night falls, perhaps we do not need to solve all of these mysteries. We only need to lie still, breathe in slowly, breathe out gently, and imagine those distant galaxies continuing to drift through the darkness. Rings continue expanding, stars continue being born, ancient galaxies continue carrying the memory of time, and we, so small beneath the night sky, also carry a universe within us. A universe that is never completely still, but always capable of transformation. Perhaps understanding that alone is enough. Enough for tonight. Enough to let the mind become quiet. Enough to close our eyes and slowly drift into sleep. Cosmic web, voids, and the giant architecture of the universe. If there is a moment that can make us feel truly small, perhaps it is when we stop seeing the night sky as a collection of individual stars and begin to see it as a vast structure stretching across billions of light years. The deeper we look into the universe, the more we realize that galaxies are not scattered randomly through space. They gather along enormous threads, broad sheets, and vast walls of matter, forming a structure known as the cosmic web. Between these immense structures lie enormous regions of surprisingly low galaxy density called cosmic voids, where we may almost feel as though nothing exists at all. Yet, much like the human mind, emptiness does not necessarily mean absence. Sometimes, it is the empty space that allows us to see the structure surrounding it. Imagine looking down at an enormous web suspended in darkness. Its threads seem to glow with countless galaxies, crossing one another and meeting in regions of particularly high density. Yet between those threads are vast expanses of space. This is one of the simplest ways to picture the cosmic web. Galaxies tend to gather along filaments, sheets, and walls, while enormous voids occupy the spaces between them. Some of these large-scale structures can extend across hundreds of millions, and in some cases more than 1 billion light-years. Still, we should be careful about calling them a single object, because the definition and boundaries of a cosmic structure depend on how astronomers identify its density and connectivity. What is truly remarkable is that these enormous structures may have grown from extremely small differences in the early universe. After the Big Bang, matter was not distributed perfectly evenly. Some regions were just slightly denser, while others were slightly less dense. Over time, gravity amplified those tiny differences. Matter gradually moved toward regions of greater density, allowing larger and larger structures to emerge. What began as extremely small fluctuations eventually became galaxy clusters, enormous filaments of matter, and gigantic cosmic voids. And here, we can pause for a moment and look at the universe through the eyes of Carl Gustav Jung. In depth psychology, Jung was deeply interested in how seemingly small and unconscious elements could gradually shape much larger structures within our inner lives. A seemingly insignificant emotion, a memory we thought we had forgotten, or a belief formed during childhood, can quietly influence how a person sees the world. For decades, the universe seems to offer a remarkably different but beautiful parallel. A tiny fluctuation in the early cosmos may have appeared insignificant when viewed on its own. Yet across billions of years of gravitational evolution, it became part of the architecture of the universe. Jung wrote in The Archetypes and the Collective Unconscious. The collective unconscious is a part of the psyche which can be negatively distinguished from a personal unconscious. This statement belongs to an entirely different context from modern cosmology, so we should not treat it as a scientific claim about the cosmic web, but as a metaphor. It invites us to consider the possibility of deeper structures existing beneath what our conscious awareness can immediately perceive. Perhaps that is one reason the cosmic web feels so strangely familiar. We look at the universe and see galaxies, but behind the galaxies, there is a structure. Behind that structure, there is gravity. Behind gravity, there is a history stretching back toward the earliest moments of cosmic evolution. And behind what we can observe, there are still questions we have not answered. The filaments of the cosmic web are particularly fascinating. They are not solid threads in the ordinary sense. They are vast regions where matter is more concentrated than in the surrounding universe. Galaxies travel within and around these structures, while gas and dark matter contribute to their overall mass distribution. At the intersections of these filaments, matter can become especially concentrated. These regions can host galaxy groups and clusters, enormous collections of galaxies bound together by gravity. And then there are the voids. At first, the word void sounds as though it should mean absolute nothingness. But cosmic voids are not completely empty. They contain extremely diffuse matter, including some galaxies, gas, and dark matter. Their density is simply much lower than that of the surrounding cosmic web. Imagine standing in an immense cosmic desert. Far away, clusters of galaxies gather like distant cities. Between them stretch enormous regions with very few galaxies. Nothing is truly absent. It is simply spread so thinly that the universe appears almost empty. There is something deeply comforting about that image. Because human beings often fear emptiness. We fear silence. We fear an empty room. We fear the space left behind when someone leaves our life. We fear the quiet moments when there is nothing to distract us from our own thoughts. But the universe does not treat emptiness as a failure. Voids are part of its architecture. Without them, the cosmic web would not have the same structure. The empty spaces help define the places where matter gathers. In a strange way, absence helps create form, and perhaps our inner lives work similarly. There are periods when we feel that nothing is happening. We are not moving forward. We are not becoming anything new. We may even feel disconnected from the person we once were. But sometimes, those quiet periods are not empty at all. They are spaces in which something is reorganizing. A belief is changing. A wound is settling. An old identity is loosening its grip. A new understanding is slowly taking shape. Jung's idea of individuation can be useful here, not as a scientific parallel to cosmology, but as a psychological metaphor. Individuation describes a lifelong process of becoming more whole by recognizing and integrating different aspects of the psyche. The process is rarely immediate. Just as the cosmic web did not appear fully formed, psychological transformation does not happen overnight. It develops gradually, layer by layer, experience by experience, awareness by awareness. And sometimes, the most important changes happen when nothing seems to be happening at all. Think about the early universe again. The initial fluctuations were incredibly small compared with the structures they eventually helped produce. Yet, gravity had billions of years to amplify them. A tiny difference became a filament. Filaments gathered into larger structures. Larger structures became clusters and superclusters. And between them, enormous voids emerged. Scale changes everything. Something that seems insignificant over one period of time can become enormous when given enough time to develop. Perhaps we can remember that when we judge our own lives too quickly. A small decision today may shape the direction of the next 10 years. A single conversation may alter a relationship. A moment of honesty may change the way we see ourselves. A quiet decision to stop repeating an old pattern may eventually transform an entire life. We rarely see the full consequences of our actions when we take them. The universe teaches us patience through its own history. There is another fascinating aspect of the cosmic web. Astronomers can study its structure to learn about the distribution of matter throughout the universe. Because light from distant galaxies travels across enormous distances before reaching us, observations allow scientists to reconstruct how cosmic structures have evolved over time. In a sense, looking deep into space is also looking backward in time. A galaxy billions of light years away is not being seen exactly as it exists now. We are seeing light that began its journey billions of years ago. The deeper we look, the farther back in cosmic history we can observe. It is almost as though the universe keeps its memories in light. Every photon carries information about where it came from. Every galaxy we observe is a fragment of a much larger story. And perhaps our own minds work in a strangely poetic way. We also carry traces of the past. A reaction may reveal an old wound. A fear may point toward an earlier experience. A recurring dream may bring attention to something we have ignored. A sudden emotion may contain information that our conscious mind has not yet understood. We do not have to accept every psychological interpretation as fact, but we can learn from the basic principle. What appears in the present may have roots in the past. The cosmic web makes this idea visible on the largest scale imaginable. The universe we see today is the consequence of an incredibly long history. Nothing about its present structure appeared from nowhere. Every cluster, filament, and void has a history. And that history extends backward through billions of years. So tonight, as you prepare to sleep, imagine yourself moving farther and farther away from Earth. Your room becomes smaller, your home disappears, your city becomes a point of light. Earth becomes a tiny blue sphere. The solar system becomes almost invisible. The Milky Way expands before you. Then the galaxies begin to gather into enormous patterns. Threads of matter stretch through darkness. Clusters glow at their intersections. And between them, immense voids remain quiet. You continue moving backward until the entire cosmic web appears before you like an enormous tapestry. There is no need to understand every detail. You do not need to know where every filament leads. You do not need to solve the mysteries of dark matter, dark energy, or the origin of cosmic structure tonight. You can simply observe. The universe is vast. Its history is long, and you are allowed to be small within it. There is something peaceful about that realization. You do not have to carry the entire universe on your shoulders. You only have to live this one moment. So breathe slowly. Let your shoulders soften. Let your thoughts become quieter. And imagine those enormous cosmic voids drifting silently between the galaxies. They are not failures. They are not mistakes. They are part of the structure. Perhaps the quiet spaces within your own life can be understood in the same gentle way. Not every empty space needs to be filled. Not every question needs an immediate answer. Not every silence needs to be broken. Sometimes, the space between things is where transformation begins. Far above you, the cosmic web continues to evolve. Galaxies move. Gravity shapes matter. Stars are born and die. Voids expand and change. And the universe continues its unimaginably long journey. You can let your own journey slow down now. Whatever happened today can remain in today. Tomorrow does not need to be solved tonight. For now, simply rest. And remember that even in the largest structure humanity has ever imagined, there is room for silence, room for darkness, room for uncertainty, and room for you to simply close your eyes, breathe, and drift gently into sleep. There are some questions that the universe seems to keep deliberately unanswered. We may have sophisticated telescopes, enormous particle detectors, gravitational wave observatories, and instruments buried deep beneath ice or rock. Yet the deeper we look, the more we discover that the universe still holds possibilities that remain beyond confirmation. And perhaps that is not something we should fear. Perhaps it is something we can rest inside. Because tonight, you do not need to know whether cosmic strings truly exist. You do not need to know whether axions make up dark matter. You do not need to know whether primordial gravitational waves will ever be detected. You only need to allow yourself to wonder. And perhaps wonder itself is one of the quietest forms of peace. The particles, matter, and structures we have never confirmed. There are nights when we lie down. The room gradually becomes quiet, and it is difficult to imagine that far beyond the stars visible to our eyes, the universe is still sending signals that we do not completely understand. There are particles that pass almost effortlessly through everything. There may be structures that formed when the universe was still unimaginably young, and there are possible forms of matter that, even today, exist primarily as hypotheses rather than confirmed discoveries. At the boundary between what we know and what remains unknown, we encounter a question that belongs not only to physics, but also to the human mind. What do we do when we encounter something we cannot yet understand? Carl Gustav Jung spent much of his life exploring precisely this territory within the human psyche. He recognized that much of what exists inside us does not immediately appear in the light of consciousness. Some things become visible only when we become quiet enough to listen. Perhaps the universe is similar. What we can observe may be only a thin layer of a much larger reality. And tonight, we can gently step toward some of the mysteries that live along that boundary. Let us begin with neutrinos. Among the strangest messengers in nature, neutrinos interact only very weakly with ordinary matter. Trillions of them pass through your body every second. They pass through the Earth itself, through oceans, mountains, buildings, and stars, rarely interacting with anything along the way. That extraordinary ability to travel through matter almost untouched gives neutrinos a special role in astronomy. When a massive star collapses, an enormous amount of energy can be released in the form of neutrinos. These tiny particles can escape from the extremely dense stellar core and travel through space, carrying information about processes occurring deep inside the dying star. In 1987, when supernova 1987A appeared in the Large Magellanic Cloud, detectors on Earth recorded neutrinos associated with the event. It was a remarkable moment in astronomy. Humanity did not merely observe the death of a star through light. We received another kind of message from deep inside it. In a sense, the universe was telling the same story in more than one language. Today, The Ice Cube Neutrino Observatory, beneath the Antarctic ice, continues searching for high-energy neutrinos, originating from some of the most extreme environments in the cosmos. These particles may help scientists investigate the origins of the most energetic cosmic rays and identify distant astrophysical sources capable of producing extraordinary amounts of energy. And there is something almost poetic about that. A particle that is nearly invisible can become a key to places that ordinary light cannot easily reveal. But as we move deeper into the unknown, the story becomes even stranger. Imagine that around a galaxy like the Milky Way, there are small concentrations of dark matter containing few or no stars. These hypothetical structures are called dark matter subhalos. If they exist, they would be like invisible gravitational shadows. They would not shine. They would not appear as ordinary galaxies. Yet their gravity could potentially influence the matter and light around them. Astronomers therefore look for their effects, rather than expecting to photograph them directly. This brings us to an idea that feels remarkably Jungian. In analytical psychology, something that cannot be directly seen is not necessarily something that has no influence. Sometimes we recognize something through the traces it leaves behind. A suppressed emotion may appear through behavior. A forgotten memory may return through a dream. A deeply rooted belief may reveal itself through a repeated pattern of choices. And in the universe, an invisible component may reveal itself through the motion of visible matter. The important distinction, however, is that a psychological metaphor is not scientific evidence. Dark matter is supported by multiple independent lines of astronomical and cosmological evidence, while specific hypothetical structures such as individual dark matter subhalos remain subjects of ongoing investigation. And then we enter an even more speculative territory. Cosmic strings. These are hypothetical, one-dimensional topological defects that could, in some theories, have formed during phase transitions in the early universe. If cosmic strings exist, they might preserve information about physical conditions from an extraordinarily early period in cosmic history, long before stars and galaxies formed. Imagine the universe as an enormous fabric. Perhaps, during its earliest moments, this fabric underwent transitions that left behind extremely thin defects. Those defects would not be ordinary objects like stars or planets. They would be remnants of the underlying physics of the early universe itself. So far, however, no cosmic string has been confirmed, and that distinction matters. A fascinating hypothesis is not the same thing as an observed fact. The same careful thinking applies to domain walls, hypothetical boundaries that could separate regions of different vacuum states. Imagine an enormous cosmic landscape in which different regions once settled into different physical states. Between those regions, boundaries might have formed. These structures have not been confirmed, but searching for evidence of them allows physicists to test theories about the early universe and possible phase transitions. Then there are primordial magnetic fields. Could magnetic fields have existed before the first galaxies formed? Could some of the magnetic structures observed in the universe today preserve traces of conditions from the very early cosmos? These remain active areas of research, and perhaps even more intriguing are primordial gravitational waves. If detected, they could potentially carry information from extremely early periods of cosmic history, possibly including processes associated with cosmic inflation. Imagine receiving a signal that had been traveling through the universe since almost the beginning of cosmic time. It would be like hearing an ancient echo from the earliest chapters of reality itself. And then we encounter names that sound almost like they belong in a science fiction novel. Strangelets, magnetic monopoles, axions, sterile neutrinos. None of these has been experimentally confirmed as a new fundamental particle or exotic object in the way that established particles have been. Some hypotheses propose that axions could help explain dark matter. Magnetic monopoles arise naturally in certain theoretical frameworks. Sterile neutrinos have been proposed as possible extensions of the known neutrino sector and, in some models, as dark matter candidates. Strangelets are hypothetical forms of unusual quark matter that might exist under extreme conditions. But for now, these possibilities remain possibilities. And that distinction is one of the most beautiful things about science. Science does not become weaker by saying, "We do not know yet." It becomes stronger. There are things that have been directly observed. There are things inferred from multiple independent measurements. There are things supported by strong theoretical frameworks. And there are things that remain speculative. Between these categories lies an enormous intellectual distance. Evidence is what allows us to cross it. Perhaps this is also a gentle lesson for us before sleep. Human beings naturally want certainty. We want names. We want explanations. We want to know where something came from, why it happened, and what it means. But the universe reminds us that uncertainty is not always a problem that must immediately be solved. Sometimes, not knowing is simply the beginning of understanding. So tonight, let the neutrinos continue their silent journeys through the darkness. Let the hypothetical cosmic string remain hidden somewhere in the deep architecture of space-time. Let the possibility of primordial gravitational waves wait for future observations. Let axions, magnetic monopoles, sterile neutrinos, and other hypothetical entities remain exactly where science currently places them, in the realm of possibilities awaiting evidence. You do not have to decide tonight which of them is real. You do not have to solve the mysteries of particle physics before you fall asleep. You can simply let the questions exist, because perhaps there is something deeply comforting about living in a universe that is still unfinished from our point of view. We are not living inside a book whose final page has already been written. We are living inside an ongoing investigation. Every generation discovers something new. Every answer creates another question. Every telescope reveals another layer. Every experiment tests another possibility. And perhaps the most remarkable thing is that we are capable of asking these questions at all. We live on a small planet, around an ordinary star, inside one galaxy among an unimaginable number of others. And yet, from this tiny world, conscious beings have learned to wonder about the smallest particles and the largest structures in existence. We have learned to detect particles that pass through our bodies. We have learned to measure ripples in space-time. We have learned to observe galaxies billions of light years away. And we have learned to ask whether something invisible might be shaping everything we can see. That is extraordinary. So, as the night becomes quieter, you can allow yourself to step away from the need for answers. Let your thoughts slow down. Let the questions remain somewhere beyond the edge of consciousness. You do not need to understand the universe tonight. You only need to rest beneath it. Take a slow breath in and gently breathe out. Imagine neutrinos passing silently through the Earth. Imagine distant galaxies moving through the cosmic web. Imagine ancient gravitational waves traveling across space. Imagine possibilities that may one day become discoveries. And then let all of those images slowly fade into darkness. Because there is a beautiful truth hidden inside the unknown. You do not need to understand everything for the universe to be meaningful. Sometimes, it is enough to know that there is still more to discover, more to wonder about, more to understand, more waiting beyond the limits of what we currently know. And for tonight, that can be enough. Let tomorrow belong to discovery. Let the future belong to new questions. And let this moment belong to rest. Close your eyes. Relax your breathing. Release the thoughts that no longer need your attention. The universe can remain mysterious for one more night. You can simply drift, quietly, gently, into sleep. There may be something rare and beautiful about our ability to ask questions in the first place. Tonight, you don't need to understand the entire universe. Just lie still, breathe slowly, and let the unanswered mysteries drift through your mind like distant points of light. Because sometimes, the unknown is not a frightening emptiness, but a door waiting for us to open. The final mysteries and the limits of human understanding Perhaps the strangest thing about looking up at the night sky is not realizing how much we have learned about the universe, but realizing how little we still know. After traveling through wandering planets, ancient stars, magnetars, pulsars, black holes, violent mergers, strange galaxies, and enormous structures stretching across billions of light years, we now stand before another kind of door. On the other side of that door is not a final answer, but a vast darkness where countless questions are still waiting to be named. And perhaps, when night falls, this is the perfect place for us to slow down, not to force ourselves to understand everything, but simply to sit quietly with the immense reality that is far greater than anything our imagination can fully contain. Carl Gustav Jung once wrote, "The privilege of a lifetime is to become who you truly are." In a deeply meaningful way, the journey of exploring the universe is also a journey of exploring ourselves. Every time we look farther into space, we also look deeper into the limits of human understanding. And the farther we look, the more we realize that humility before the unknown is not weakness, it is a form of maturity. Let us begin with antimatter, one of the most familiar yet mysterious concepts in modern physics. Antimatter is not something purely imaginary. Antimatter particles have been created and observed in laboratories. When a particle of matter encounters its corresponding antiparticle, they can annihilate each other, releasing energy. But what troubles scientists is a simple yet profound question. If matter and antimatter were produced under the conditions of the early universe, according to laws that were nearly symmetric, why is the universe today dominated by matter? We exist because, somehow, that balance was broken. A tiny excess of matter survived over antimatter. And from that small imbalance, billions of galaxies, stars, planets, and eventually ourselves came into existence. So the question of antimatter is not merely a question in particle physics. It is almost a question about the origin of existence itself. Now let your mind turn toward ultra-high energy cosmic rays. Some particles from space enter Earth's atmosphere with extraordinary amounts of energy, far beyond what conventional human-made particle accelerators can produce. They collide with particles in the atmosphere and create enormous particle showers. But the precise origins of these extremely energetic particles remain a mystery. They may be associated with some of the most powerful environments in the universe: active galactic nuclei, relativistic jets, remnants of dead stars, or other extreme environments that we do not yet fully understand. What is astonishing is that these particles may have begun their journey in a place millions, or even hundreds of millions, of light years away, before finally reaching the atmosphere of a small planet. A journey so vast that it is almost impossible to imagine, ending with a signal that human beings are capable of detecting. And the universe contains states of matter that make the very concept of matter seem much stranger than we normally imagine. Positronium, for example, is a temporary bound system made from an electron and a positron, showing that matter and antimatter can briefly exist together in a unique structure. Muonium is another unusual atomic system in which a muon takes the place normally occupied by an electron. And Rydberg matter demonstrates that highly excited atoms can form collective states that behave very differently from ordinary matter. These examples remind us that the physical world does not necessarily have to resemble our everyday intuition. What we call normal is actually only a very small region within the enormous range of possibilities allowed by nature. Even here on Earth, we have a remarkable kind of time capsule known as Oklo. Billions of years ago, in what is now Gabon, natural conditions allowed a self-sustaining nuclear fission reaction to occur. No human designed it. No laboratory constructed it. Nature itself created a form of ancient nuclear reactor. It is almost like a message sent from the distant past. Earth once possessed conditions that humanity would only begin to understand thousands of years later through the development of science. But if Oklo preserves evidence of a process that occurred here on Earth, then pre-solar grains take us even farther back. These tiny grains of dust, found inside certain meteorites, existed before the Sun and the solar system were formed. They carry chemical signatures from stars that died long before the Sun was born. Try to imagine that for a moment. A tiny piece of matter may have existed before the Sun itself. It wandered through interstellar space, survived the formation of a new planetary system, and eventually became trapped inside a meteorite that reached Earth. Billions of years later, human beings found it and were able to read the story of a star that had disappeared long ago. Some forms of matter are so rare that nature can barely preserve them for long. Astatine is one example. It is extremely rare in Earth's crust because all of its isotopes are radioactive and have relatively short half-lives. Beyond that, we encounter super-heavy elements. Elements so massive that they can generally exist only under very specific conditions and often for extremely short periods of time. Once again, we encounter a beautiful paradox. Some things are rare not because the universe cannot create them, but because they cannot survive for very long. And then, on a much larger scale, we encounter the CMB cold spot, an unusually cold region in the cosmic microwave background. It is not necessarily a crack in the universe, nor is it definitive evidence of some hidden cosmic phenomenon, but it remains interesting because it connects to larger questions about the statistical properties of the early universe, large-scale structure, and how we interpret unusual features in cosmological data. This is where science becomes most beautiful. It does not rush to turn an anomaly into a miracle. An unusual signal may represent a new discovery, but it may also be a statistical fluctuation, an observational limitation, a systematic error, or an incomplete interpretation. Science matures through its ability to distinguish between what we want to believe and what the evidence actually allows us to say. And after all these journeys, we return to perhaps the biggest question of all. Is intelligent life truly rare? Among all the worlds humanity has observed, Earth remains the only place where we know with certainty that intelligent life exists. We have discovered thousands of exoplanets. We have detected organic molecules, environments that may be suitable for complex chemistry, and we continue searching for technosignatures that could reveal evidence of another civilization. But so far, there is no confirmed evidence of an extraterrestrial civilization. That leaves us with two possibilities, and both are breathtaking. Perhaps intelligence is common, and the universe is filled with worlds where beings are looking up at the sky just as we are. Or perhaps the emergence of a civilization capable of self-awareness, capable of asking questions about its own origins, is an extraordinarily rare event. If that is true, then our existence becomes special in a very different way, not because we stand at the center of the universe, but because, in one small corner of space and time, matter has reached a state in which it can look back at itself. Perhaps this is also what Jung invites us to contemplate. Human beings do not simply live within the world. We continually create meaning from the world. We look at the stars and give them names. We look into darkness and search for answers. We listen to the silence of the universe and wonder whether someone else, somewhat far away, might also be listening. But tonight, you do not need to find the answer. Let all these unknowns rest beside you. The particles of antimatter, the ultra-high-energy cosmic rays, the ancient grains of dust that existed before the Sunday, the rare elements, the strange features hidden within the oldest light of the universe, and the question of whether another civilization might exist somewhere beyond our reach. All of them can continue to exist in the darkness, even as you close your eyes. Because the universe does not need us to understand all of it in order to be magnificent, and human beings do not need to have every answer in order to be at peace. Perhaps growing older, And perhaps growing wiser sometimes means simply learning how to live alongside questions that do not yet have answers. Tonight, let your mind become lighter. Imagine Earth quietly drifting through a sea of stars, a small planet, a brief moment, inside a universe so ancient that its age is almost impossible to comprehend. And somewhere in that darkness, the stories we do not yet know are still unfolding, without urgency, without needing to be explained immediately, simply existing, like dreams waiting for you to enter them. And perhaps the final boundary of knowledge is not where the story ends, but where a new question begins. And now, after traveling together through such a long journey from wandering planets drifting through darkness, ancient stars older than the sun, magnetars with terrifying magnetic fields, invisible black holes, violent cosmic mergers, strange galaxies, enormous structures spanning the universe, and tiny particles that can barely be seen. Perhaps it is time to slow down. There is no need to search for anything else. No need to know the answers to every question the universe has placed before us. Just lie still. Relax your body, and allow the images that have passed through your mind to slowly settle. There is something truly strange about our journey of exploring the universe. The more we learn, the more we realize how little we still know. Every answer seems to open the door to another question. When humanity discovered exoplanets, we began asking whether life might exist there. When mysterious radio signals were detected from deep space, we wondered where they came from. When we observed black holes, we began asking what truly happens beyond the event horizon. When gravitational waves were detected, we realized that even space-time itself can vibrate. And when we discovered ancient grains of matter older than the sun, we understood that part of us once existed inside stars that no longer exist today. Perhaps we often imagine ourselves as beings standing outside the universe, observing it. But in reality, we are part of the universe trying to observe itself. The elements that make up our bodies were once forged in ancient generations of stars. The carbon in our cells, the oxygen in our breath, the calcium in our bones, and countless other elements passed through cosmic processes billions of years before becoming part of us. That makes the existence of every human being truly remarkable. Not because we are grand, but because we are so small, almost insignificant in the vastness of space. And yet we possess the ability to look up at the night sky and ask, who am I? Where did I come from? And is there anyone else looking at the stars just as I am? These are questions that Carl Gustav Jung explored in a different way. For Jung, the journey of exploring the outer world could also become a journey of exploring the inner world. When we look into the darkness of the universe, sometimes we are also looking into the darker regions of ourselves. When we become curious about what remains unknown, perhaps we are also confronting the unknown parts of our own minds. And when we accept that the universe has no obligation to give us every answer, we learn to become gentler with ourselves. Not every question needs to be solved immediately. Not everything we fail to understand needs to become a source of anxiety. Some mysteries simply need to be observed, just like the night sky. You do not need to know the name of every star to feel its beauty. You do not need to understand an entire galaxy to feel small beneath it. And you do not need to explain the complete origin of life to feel grateful that you are here, experiencing this moment. Tonight, imagine that you are standing somewhere completely quiet. No traffic, no phone notifications, no work waiting for tomorrow. Nothing that happened yesterday. Just you and an enormous sky above you. Somewhere in the distance, the light from a star may have begun its journey hundreds of years ago. A photon left the surface of that star, traveled through the cold emptiness of space, passed through clouds of dust and gas, and finally reached your eyes. You see it for only a moment, but that light has traveled through a small part of the history of the universe to reach you. And perhaps your life is like that too. You are living within a very brief moment, a small stretch of time between an endless past and an unknown future. But being brief does not mean being meaningless. A beam of light may exist for only a moment when it reaches your eyes, yet it can still make an entire night more beautiful. A human being may live only a few decades within a universe billions of years old, yet still have the ability to love, think, forgive, create, and leave a little light in the lives of others. Perhaps that is what tonight's journey is meant to leave with you. You do not need to become something extraordinary for your existence to have meaning. You only need to be present, breathe, feel, and allow yourself to rest. The questions surrounding antimatter are still there. The origins of ultra-high energy cosmic rays are still there. Strange particles and unusual states of matter continue to be studied. The mysteries of dark matter, dark energy, and the early universe are still waiting for future generations of scientists. And the question of life beyond Earth still has no final answer. But tomorrow is still waiting. A new generation of telescopes may see farther. A new detector may hear a signal that has never been detected before. A young scientist may discover something that today we cannot even imagine. Perhaps one day, one of the mysteries we have talked about tonight will finally be solved. But perhaps every new answer will simply open 10 more questions. And that is perfectly okay. Because perhaps the universe is not a book that we are meant to read all the way to the final page. It is more like an endless dream. Every time we think we understand it, another door opens and we step forward again. But tonight, you do not need to go any further. Let the journey end here. Let distant black holes become gentle dark points within your imagination. Let ancient stars become tiny lamps scattered across the sky. Let radio signals traveling across billions of light years become a distant whisper. And let that entire vast universe slowly become smaller, until there is nothing left but the quiet room. One breath, one heartbeat, one body resting. You do not need to explore anything else now. You do not need to think about tomorrow. You do not need to solve yesterday's problems. Just allow your mind to rest. If you have had a long day today, give yourself permission to put it down. If something has been worrying you, let it remain outside your sleep for a while. If there is a question that still has no answer, let it stay there. Not every question needs an answer before we close our eyes. Sometimes, all we need is a little peace. And perhaps, during tonight's sleep, your mind will quietly travel to places your conscious awareness has never visited. A distant ocean, an unseen planet, a star being born, a galaxy slowly turning through the darkness, or perhaps simply a sky filled with stars, where you stand alone and feel completely at peace. Thank you for staying with me until the end of this journey. If these stories about the universe, the human mind, and the deeper mysteries of existence give you a peaceful moment before sleep, please subscribe to the channel and turn on notifications so you don't miss our next journey. Each night, we will step away from the noise of everyday life, travel through the distant reaches of the universe, and sometimes return to explore the depths of our own minds. If you'd like, leave a comment and tell us, what do you think is the greatest mystery humanity still has not solved? Perhaps your answer will become the starting point for another journey. But for now, turn off the light if you haven't already. Put your phone down, close your eyes, breathe in slowly, and breathe out gently. Imagine Earth drifting peacefully through the darkness. No rush, no noise, just a small planet slowly turning beneath the light of the stars. And on that planet, you are lying here, safe, quiet, free to rest. The stars continue to burn. The galaxies continue to move. Black holes continue to exist silently. The universe continues to expand. But you don't need to go anywhere. Tonight, let the universe continue on its journey. And you, let your mind rest. Let your final thoughts slowly dissolve, like the light of a distant star, gradually fading into the gentle darkness of the night. May you have a deep, peaceful, and gentle sleep. May your mind find rest, your heart find peace. And when you wake tomorrow, may you feel just a little lighter. Until we meet again, on another night, with another story and another mystery of the universe. Good night.